All right, we're back with more from the DSPy series. Welcome back if you're watching on YouTube. Let's see, so where did we leave off? We did a lot of progress last time because we actually started working on the we started working on templating, right? So we did the split. But actually what I wanted to do, because this is kind of tricky to track, let's try to draw a diagram for what we're trying to do. Like a nice AI diagram, right? So we can go, what the heck is this? Oh, okay, we can just start drawing here. So let's see, what modules do we have so far? What is the state of the project? Well, let's see, let me switch. So, I guess we have a, whoops, how do I write here? So we have a problem solver. Okay, so let's competitive coding problem solver, and this is a DSPy module. Now what it does is it takes as input a problem solving signature with, how much do we have here? Let's see. So we have our competitive coding problem solver, and we have the problem solving signature. And how many inputs did this have? This is a good recap. So it had 2 real inputs and 5 outputs, the signature. So how do we represent DSPy? So 2 inputs, 5 outputs, 1. Now, let's do it this way then. Let's say this sort of, no, because, and this signature will inform our solver module, right? Can I not snap these? Wonder. So that makes this guy have inputs and outputs, which are defined by the signature, right? So then the inputs for this guy are problem description and optional test cases. Okay, so input output pairs, let's call them that way, which are really tests, okay? And what are the 5 outputs now? The 5 outputs are, we're just going to represent as blocks, or let's represent them as rhomboids, because they're all different, right? So there is a solution code. Maybe this isn't the best. Let's do still a rectangle. So there's a solution code. There is a runtime measurement code. There's a memory consumption measurement code. And this is very important. There is a test code, correctness test code. And there's also another output which we sort of added just for fun on one of the previous streams. But I think it's an interesting output because, let's think here. What did we call it? Explanation, an explanation of the implementation of the solution. Okay, so there's also an explanation or justification code. No, not code. This is natural language. So this is NLP explanation. So we have 4 code outputs and 1 natural language output. Okay, natural language output is okay. Let's turn the input into boxes too. So the inputs are problem, NLP problem description. So natural language, right? Okay. Let's do it like this. Okay. And there's also some code which represents optional, which is an optional input, test cases. Or let's call it input output pairs. Now, okay, so then and actually let's color code these then, right? Okay, so the explanation, problem description, and optional input output pairs. Now, so we can say whatever is colored with green is code, and whatever is colored with blue, we should do this. Okay, natural language. Or what would DSPy call strings, right? So just descriptions of things. So then we're gonna have blue here. And we're gonna have green here. Okay, now, okay, so the competitive coding problem solver has to produce these 5 outputs given the 2 inputs. Okay, this is starting to look clearer. And it has this signature. Let's code signatures in yellow and DSPy modules in red. Okay, so then we're gonna have 2 more concepts here which are a bit different. So DSPy module, DSPy signature, and we're gonna need a 3rd color for the one very important block which is not really shown here, but is the adapter. Okay, so let's see, signatures in yellow, modules in red, adapters in just plain white. Do I have more colors here? Oh, I do have more colors, yeah. Purple. Okay. All right, so these are all the concepts we need. So now what, this is the main code so far, okay? The first thing we did is that we determined that because all these solutions are produced at the same time, they must be coherent with respect to each other. So there's actually a hierarchy. There's a topological order between the pieces of code output by the module. They must depend on each other, okay? So let's represent that. So first and foremost, the solution doesn't depend on anything, okay? But then the runtime measurement, the runtime consumption measurement, and the runtime measurement, the memory consumption measurement and runtime measurement blocks, let's order them like they were, runtime memory consumption. These guys do depend on the solution, okay? So let's, somehow we need to mark that. And then the correctness test depends on all three of them. And then the explanation also depends on the solution. So how can we mark that? Maybe we'll do overlapping blocks then, right? So the solution is the most atomic component. These guys, let's see, is there a transparency here? Send to back. Okay, so these guys must include the solution. Right, so memory consumption measurement is some code that includes the solution and something else. Runtime measurement is similar, but it doesn't include the solution. I mean, it doesn't include anything from the memory consumption. And the test includes everything. So the test is easy to show. It will be something like this. Right. Yes, okay. Now, how do we show the runtime measurement? And the explanation is actually independent, right? It's just a natural language explanation. It doesn't really depend on the solution. Let's just call it memory consumption / runtime measurement. So we have an easier diagram. Okay, so this is a nice hierarchy because in whatever, okay, now the explanation is natural language. That one is easier. Is there a group button here? Let's see. Yeah, there is a group, perfect. So we can group all these to stick together, the explanation. Okay, we haven't said anything, notice here, about how these includes are generated and the project structure, okay? So the final thing that goes into here in our solver is a project structure, which is kind of the same thing as a signature. Not really, it's a special thing, right? This one has, it is a special thing. But it oversees everything, right? Because it dictates absolutely everything. Okay, so how do we want to show that? So let's say it's also an input, right? But not to the signature. Now there is an adapter here. The adapter that we wrote. Okay, so now we can finally move on to the adapter that we wrote so far in one of the previous videos. So what adapter did we write? We wrote an adapter in project.py that is aware of the file structure and can generate instructions for the AI on what kind of include commands or include what kind of code to write to ensure that all these fields are properly include each other. Okay, so in this case, our dependency is the memory consumption and runtime measurement codes, which are fields. That's why I said fields, but they're really code. They must include the solution code. They must not duplicate it, but actually use a proper include or import statement. Okay, so we're keeping that vague because we haven't said anything about what programming language we want to solve this in. And this is also the AI model, of course. So let's see, can we insert a symbol here? We can insert a symbol. Right, so this is the AI module. And there is an adapter. Okay, so there's a file adapter, very important, which is a DSPy adapter that is aware of the project structure and based on this, it generates instructions for the competitive coding problem solver. Okay, so the signature also generates instructions. The signature is what tells it, is what describes what the inputs and outputs should be. Okay, of course, the competitive coding problem solver at runtime sees the actual problem description and input-output pairs, but this file adapter is also aware of the project structure, which tells the competitive problem solver, hey, make sure this code properly includes other code that you generated, right? So in this case, make sure that the memory consumption runtime measurement code includes the solution code. Make sure the correctness test code includes everything, solution and the memory consumption and runtime measurement, because this is the hierarchy we have so far. So, okay. Now, this file adapter, we wrote one by hand, okay? So manually written for Python. But let's not do it like this. So let's say this file adapter also has another very important input, which is the programming language. Which right now we just wrote the file adapter for, and this is a natural language input, right? So we just wrote a file adapter for Python. Okay, so let's also make, let's see if we can make. So let's also call this files info, files on disk, right? Because this is what this will be. Or rather, we should say file system info, okay? All right. So now what we need to do today is break this line here, because we don't have a file adapter that can take as input a programming language and magically generate instructions. And there's another thing here. The programming language also informs the project itself. And the project itself, how can I do a bent arrow? Here we go. Perfect. So back to what we were saying. So the programming language also informs the project structure, which project structure module, or this is still in the main, but this information is not only responsible for informing the file adapter, but it also actually writes the code to disk. Okay, so that given the instructions, okay, that this guy generates, it's actually coherent with how the code is written to disk. We don't want, here we're going to take some power from the AI, right? We could let the AI write, we could also have this DSPy module decide where to write the code to this, but we don't want to do that. Instead, the project structure has a predetermined way of writing code to disk, which is given all from the programming language. And then this same programming language and the project structure informs the file adapter on what kind of prompts to generate for the AI module such that the pieces of code are coherent and correct given the project structure and the programming language. Perfect. This is what we have today, but only for Python, okay? So what we need to do today is very, very simple. Write 2 more DSPy modules. Okay, one of them will be called adapter writer, and this is still AI based. And we want this to be aware of the programming language and write the file adapter for us. Instead of what we did today is we manually wrote this for Python. Okay, so we have one here and one here. Okay, the other thing we would need to do is, let's think about this a bit carefully now. Yeah, we're gonna have to write a project structure. Let's call it the project manager, which is kind of an overloaded term, but we can call it this. And this guy should also be language aware. Okay, so we want all starting from the programming language. Generate an adapter for me. Well, now it's also clear what the order of these guys has to be, because first we need the project structure. Okay, so the first module we'll have to write is the project manager, which takes a programming language and writes code that handles the project structure and writes the files to disk. Very important, very, very important. Then once we have that project structure, we fix it, then we can write another AI that there is a trickery here, because this AI itself will be aware should be aware of the project structure now, because it becomes metadata for it, right? Unlike before where there was no AI. Okay, and then being aware of the project structure, this AI needs to write a file adapter, which itself is also aware of the project structure, and finally generates the right prompts for the AI to solve this in any language. Okay, so this can be any. This is the goal that we want. We want to write something that ultimately can solve coding problems in any language. Okay, this looks not too bad. I don't know how to save this. We'll keep this open for now. So we wrote the first thing. This guy is language agnostic because the way DSPy works, the instructions are generated by an adapter, which is good because it separates the signature from the language, right? And we already modularized the part where we have a dynamic language using DSPy.code fields. So that part is good. Then we need to start writing these two adapters. And for that, we split our project into some files and we can finally start coding now. But let's see, let's switch a bit to what do we need to do for today. Well, this is the high level goal, right? The DSPy. We split the templates last time. So we wrote to we split the templates. Write to execution paths with two adapters, yep. So let's see, to-dos for today. Right, implement the project manager DSPy module that writes outputs to files. No, that outputs code that writes outputs to files, okay? Because outputs code, which, okay, because we still want to stay in Python as the whole meta code, right? Let's think of it that way. We still want to stay in Python land. So we're gonna have this module write some Python code which writes outputs, which now will be arbitrary language outputs, to files, or let's say to a file structure, a folder, to a project structure. And the other responsibility is generate. Well, no, I think we said last time the project structure we have today should be generic enough. It's we have to write some generic code somewhere, although not really. The whole point of AI is you can you're supposed to do everything with AI. But I think the way we wrote the project structure, it's just every file has dependencies, which I think we kind of said, okay, maybe this is generic enough. For many programming languages, the concept of dependency between files is pretty fundamental, right? In C, you can include, in Python, you have import statements. In Rust, you have use statements. MATLAB has, I think it has use statements too. JavaScript, whatever, etc. Okay, so let's see, where were we? And how are we going to write all this? So use strong templating. Use Python unified diff library. Okay, because the way we wrote our templates is that we left to-dos in the code for the AI to populate. This is all nice and fine. We're gonna pass this to the AI. See here, we write something in the project class, right? Which just adds a suffix to files. Now this one is easy because based on the language, AI will do this easily. The harder part about so this is our project manager, okay? Actually, the job of our project manager will be to write these two data classes, the project and this function. One data class and one function, okay? So the project class, the fields are static. We have a language and a list of files. We're assuming that this is strong enough to capture a project in any programming language, which may be wrong. But if we do end up adding stuff, we'll add it universal. Although again, AI could just write this whole class for us, but it gets hairy because we want to we also want to use this in main. So then if I have to, it has to have a unified interface, right? Universal interface across languages. And that interface is files. So we can assume the project is a list of files, which is another data class, which is also part of the universal interface. And one file is characterized by a path at which it's found on disk, and a list of dependencies, which are other files. And based on a given project with some files, we have a dependency map and a file map, but what's missing is a way to write all the files to disk, which can be different in different programming languages, right? Like Rust wants you to keep all your files in an SRC folder, and then you'll have nested projects. Python doesn't really care. You can keep the files loose in the root folder and then have subfolders there. C also doesn't care, etc., etc. So, but also Python needs init.py files to register folders as modules. All these subtleties will let AI implement this. Now the problem is, let's say we give this to the AI to implement. How do we know it only modified these two methods? Okay, because our rule is we would like AI to only modify these two methods, nothing out of scope. Well, for that, we're going to use the Python unified diff library, which returns a list of differences. And if we see anything else changed on the outside, we can reject that and give feedback to our DSPy module, to our project manager DSPy module. Okay, so let's begin. So, generate is the adapter module, which will go a bit later. Where do we import this from? Stream.project import project. Okay. This is fine. So let's write the new file. Which is pm.py, okay, for project management. And so how do we want this module to look like? Well, we're gonna say, now all DSPy modules, they need to start from a signature. We've seen that many times, right? So let's start the signature. So project manager, which is a DSPy signature. Okay, well, it cannot depend on the project field because this is not written now. Instead, it'll depend on what is the input to. So it has a doc string, okay. Okay. And it must have at least one input and one output field. Now the input and output for this are pretty related because they're both going to be Python code. Okay, so the input it's DSPy code Python. And it's a DSPy input field with the description. And the output is output. Okay, so the input is a template. and the output is a filled template. We're just going to call it filled. Okay, and what are the descriptions and what's the doc string? So what do we want this project manager to do? Now this should be brief because you're not supposed to write many prompts by hand in DSPy. That kind of defeats the purpose. Well, the description of this should be: you are an expert in using Python to manage multi-project files, multi-file projects in arbitrary languages. Aha, so we need a language, very important. Okay, so this module will need to know, very important, what programming language am I supposed to write the project structure for? Description: the programming language of the code files. Template. Okay, so your languages. Using the Python template, populate its missing methods with code that, now we're not going to describe these because we want this to be generic, with populate its missing methods with code that populate these missing methods with code. That's enough. Only touch the methods that so we're also going to have a feedback. Well, actually, let's see. Can we reuse our feedback mechanism? We can, right? Because we wrote some iterative code execution feedback, and which makes our diagram a bit more complicated, but we'll leave that for now. Only populate methods. Populate is missing code. Only populate methods, classes, functions containing the to-do current functions marked with to-do and nothing else. Okay, so what else do we want this AI to do? So let's say I get a candidate fields. Okay, so the template, the language is the language. The template is do not add new code outside of the to-do scope, nor remove existing code. Your solution will be strictly checked and graded against these requirements. So what we also want to do, we want to make this iterative, because if the model fails to obey here, if the model does decide, oh, you know what, I'm actually gonna need a new field here, which is called stuff, we want to disallow that, okay? Now, again, this does imply we need to be smart when we write the static parts and that they're useful enough. But I think these are useful enough, if I'm not mistaken. But we'll see. We'll do a trial run. Now, okay, so it has the template. the template to be populated, and the code is the populated template. Okay, so this is a basic signature with 2 inputs and 1 output, and that's it. Now all we have to do is read these templates from file, and then Python allows us to inspect the source code. Okay, so we'll get exactly this as a Python string, and we'll feed it to AI, and that's it. We'll get a solution, and then we can compare it with our... We have an example for Python here. Okay, so the suffix is just return py. Initialize modules is make the directory and write the init file in it. Let's add more instructions here. The way the project is structured should be coherent and ensure coherent, idiomatic, and ensure 100% functional, and ensure that execution is possible. Okay, so you have to write, you can't just, because something tempting to do is just write all the files in the same folder. But that means you're not taking into account which the AI will see. So the AI sees in the template that the file has the depends on field. So then when in this initialize modules, we'd like the AI to take care of that. The other thing is for a function, I think we're going to do both functions at the same time. So, or should we do them separate calls? The function should write the Python array to a global variable. The Python array to a global variable in the given language. And we can use ... here, right? Yeah, to signify not implemented in the template. Okay. Use statements are a different beast and code execution, but we'll get to those later. Let's see if we can do file management though with AI first. Okay, so we have the project manager. And all right, next step would be we'll have to write the main for this, right? Yep, because this will have to be, or let's say we'll have to write the main like this, and then if name is main, okay. And for this, we need all the DSPy isms too, right? We're gonna need args too, yeah. So we're gonna have to import arg parse, because this will have its own args now. Which actually, how many args do we have here? With files, 4. We can just copy some of this code here. Let's see. So what args? Do we even need args for this? not too many, right? Language is no longer an arg. Feedback. Yes, we need feedback. We're gonna want to try execution feedback here. Oh, is this not how it happens? It should be, right? Oh no, I see. Okay. So we have to write the main function now. Okay, we're gonna have to take some DSPy-isms from here because we have to, well, the only thing is we just need to instantiate DSPy with the model, and that's it, right? Yeah, I'm pretty sure this is it. Okay, we can close some of these guys. And we need the OS too. Okay, so instantiate DSPy with the model, and then we're not gonna create the folder structure anymore. We have the signature. We're just gonna use DSPy predict then. So then our instance will be called PM, so project manager. It's just DSPy predict with this signature, with project manager. Okay, now we have the module. What are the runtime inputs? This is it now. So we're gonna need to inspect the source, right? So instantiate the module. So this is it. This is our DSPy module that we had in the diagram. This is the project manager module. So we have this at runtime now. Yeah, good. So now we just have to pass the inputs to it. Of course we need the language because we'll want the user to ask for a language now. It won't be in a language, but the user will just ask for language, which is how do we do language? Let's just do it here. Here we go. So we're still gonna need a language input because we want to ask this module to generate something from a language. And then let's see, we're gonna have the prediction. It will be project manager inputs, right? That's how we call it. So we just have to form the inputs, right? Well, the inputs are not too many. There's the language, which is just the string. It's just the language, okay? The second input is we have to fill the template, which we'll do with Python inspect source code, okay? So for that, we're gonna have to import from ideas dot, from streaming dot, from stream dot, oh, there we go, language dot template import. We said we want to populate two things, project and the function. Write jagged array to file, okay? So then the template will be project inspect. So we need a Python inspect source module then. Python inspect source code of class, for example. Oh, it's just the inspect.get source. There we go. So all we need is import OS import inspect, okay? And then we say inspect dot, actually we're gonna do, let's see, we're gonna separate them by two new lines, dot join. And what's the list of code that we want this guy to see? Well, this module to see. Well, we're going to want to see the source code. What was it? Get source? Okay. Of project. And the other is after this, the order won't matter here because it's just write jagged array to file. Get source, write jagged array to file. There we go. So now we have the prediction with 2 inputs. DSPy predicts so now we want feedback, right? Do we not use the feedback flag here? What's happening? Oh, I see. Module with code feedback. What is module with code feedback? This is good, but it's not generic now because it depends on a project. So now we're stuck in a loop here because if we want this thing to have feedback fields using the previous code execution feedback we wrote, this is kind of there. It will try to execute Python code. In this case, there's only one output, which is the filled, so it'll try to execute the code here. Which it does how? Just by a UV run, right? Which is what we want to do. Where is the execution? Execute code. But there is a trickery here because this execute code, yeah, it's imported from Python. So this may actually work because this is a Python meta project now. Okay, this works then. We can actually reuse this because we'll have to create a new project, which is different than the project we want to instrument, but it's our actual project. Okay, so good. So create the Python meta project. Right, and it's kind of similar to main, except which will encompass the project management code. Okay, because even though the code manages a project at runtime, this code itself is also managed in the project. The only trickery here is that this is always Python. Okay, because we say you're an expert in using Python. Okay, so at least we have this invariant. Okay, across all no matter what programming language we want the AI to generate the solution, we're always going to execute it from Python, and we're going to manage the files of the solution from Python. So then this project will actually not write an output, but it'll write directly in the source and src folder stream language, and it'll write the file which is pm_languagename.py, where language name is language. So we'll write the pm_python file. Okay, even though Python we already have and completed, but once that gets validated, we'll have that be overwritten. Yeah, I think this is great. So let's do this way. Let's do it this way then. So we need a Python meta project now. This is pretty easy because cases, project structure. We'll just write this by hand, right? Well, it only has one file. Okay, so this project is a bit special because it only has one file and it has no dependencies between files. Okay, so then the execution will be trivial then. We'll just use UV to attempt to run that file, which just validates if the Python syntax is correct, essentially. Because this file will not have a main. But we can also add test code then. Interesting, so we could add test code here, which actually exercises. Yes, I think we should definitely do this. Very good, good idea. So, so let's do it this way. Let's make a new folder in language, which is called template. Okay. And this file, this will be a new module now. It'll be init.py, okay? And there will be a template for the pm.py, not to be confused with the actual PM code. Now, that template only has these two things. Whoops. Sorry. Some mouse issues. Okay. And let's see, what do we not need from here? We don't need subprocess, but very importantly, okay, and now we can actually read this whole file. We don't have to build the template from pieces. Yeah, oh, sorry, did I take generate use statement too? Yeah, we don't, this is not for the PM. But more importantly, this can have a main now, which does something. And it can have an if name main. And actually it can just have this then. So this is test code now, okay? Because we can actually run this with UV or with Python-M now, which is very important. And we can remove these from the template. We'll strip this template. This template will eventually just die, go away. But for now, we can just cut pieces of it. So we don't need these anymore. Oh yeah, we don't need a ton of things then. And this will be this is the other template for the other module. So we'll need for the adapter, which we drew earlier, we'll need something that generates use statements for a location. We'll have to think about this carefully. Something that executes code, which is also for the adapter. We'll also have to think about this carefully. Now this project here is from from stream dot language completed PM import project, because we're gonna want this code to live there. So we'll have the PM write the folder in, and it'll also write the pm.py in the completed folder. I mean, the AI will write there. Okay. Yeah, this looks pretty good. Let's see what else. Okay, we're starting to get organized now. So okay, but this, and also this is another template, by the way. This is the template for adapter.py. We can just take this here and we'll live here. And now we can delete this template file. Okay, so now language only contains two modules, pm and generate.py. I guess this should be instrument. yeah, this should be instrument. The only problem is it's yelling that the PM file does not exist, so we'll just touch that file then. Completed should have a pm.py file. Okay, now this one is not going to yell. And then I guess for now, we don't know how it's going to look like, but sorry, let's remove this pycache. Delete. Okay, and completed will also have an instrument.py. Okay, so we have 3 versions of the same file name, which different roles, right? So first, the file in the Python module in PM is the actual DSPy module, which uses the template of the same name and writes the populated template to completed. Okay, so now let's go back to this guy. So now, first of all, the input has changed and it is no longer, we're not gonna have to get sources anymore. Instead, what we'll do is we'll just say, we're gonna need pathlib. We're just gonna read that file as is, all of it, right? So we'll say path. What is the path? Good question. So we'll have to feed this as an argument. Template path, right? Type str default help path to the template file. Because we're gonna want this interface for the instrument anyway, so we might as well do it. Let's close some of these guys now. Let's see here. So how do we represent the paths here? I'm a bit confused because if I run, how do we represent the paths here? Name cases. I guess these are all relative. Okay, so let's try like this then. src stream language template pm.py. Okay, and then this will be just path of args.template path dot read text. Okay, that's it. We'll leave it with join because we may want to add. No. If we do want to add things dynamically, we'll just change the template file, right? We don't want to make our lives more complicated. Okay, let's try to run this now. I want to see what's happening with the path here a bit. So first of all, we do UVX rough format. Okay, it's gonna change a few things here. Okay, reformat our file a bit, great. Git, yeah, we did a bunch of stuff. We're gonna have to completely redo this, but my point was that, oh sorry, I don't have the files. Now let's go back. So there's a single Python meta, there's a single file without dependencies. What is that file? Well, it is a file called PM. Remember, this has to be the module name in Python. Okay, so then we'll have project, it will be project. Now we need to import this project, but from the solved. Okay, so from stream dot language dot completed dot Python import project. So this is the kind of project. And what does it take to initialize? Language, it is Python, universal. This is a hard code here because the instrumenting code lives in Python, guaranteed. And it also has files. Okay, good. It has the files. And the files itself is what is the files? Oh, it's a list. Okay. Oh, it's just a... Okay, so it's a project.file, a single file, and it has a path. What is the path of this file? And it depends on nothing. Right? I hope I got this right. Yeah, default factory list, so nada. Depends on the factory list. Path. We just need a path. And the path is src stream. So where does the written code live? It lives at language, completed, PM. Do I have to put the dot here? How do I do this? No, at PM. There we go. And we have a project manager. And now we also need to get an adapter. Here we go. So we do want feedback. So then the module becomes exactly like this. So where's the project manager? Here it is. If we're using feedback, then the project manager is itself, but wrapped. I guess we can call this project structure. And this we have to import from stream.feedback, import this thing. Perfect. So now when we put the feedback flag to true, this will say, okay, this DSPy code has generated, there's another assumption that we encoded. The file name must be, very important here, exactly the same as the field name, test memory runtime. So if I call this PM, I'd better have this PM, right? Because my file is PM. So then the field PM from DSPy will get routed and written to this file by this module, which itself uses, well, is aware of the project and leverages its initialize thing. Or does this depend on, do I have to initialize the project on the outside? Yes, I do have to initialize the project on the outside. Very careful here. Another thing is that we again have to, this is perfect because now we're reusing the pieces. We also have to make this project manager aware of the project structure, which is fine. Because this is a fake field. It's exactly what we did before. Okay, so we're gonna need, we're gonna need to move this in just because it's easier not to capture context. There we go. Okay, so this is a fake input field. And what adapter do we need to use? Is there an adapter trick here too? Who excludes the... Oh no, there is no adapter trick because we just omit this field from runtime. Gotcha. There we go. So project none. Okay, so we have to put it a dummy input. Okay. No, there is an adapter field, right? We have to use the same adapter. This is universal though, because this is the fixed file adapter. So from stream.project import file adapter. And this guy, what? LM, reorder upload fields, process signature. This is the guy that executes. Well, actually, we don't really need to use this. We just, here it is. Yeah, we need it for the delete, but not for the instructions. Okay, this is fine though. But why do we need the project at all? Does this module rely on seeing project at runtime? I actually think not. So actually, you know what? This can be a lot simpler. I don't think we need this fake field here. This fake field is only useful to generate instructions. Yeah, let's try it without this. So we can just use the regular chat adapter. So this already writes the code to disk, right? Predict and write the code to disk with execution feedback. Now, one more thing though. We have to do two more things, not one. We have to finish the template because our template that has no main, so this will always run now, or it'll always crash. I guess this will raise unimplemented. We also have to verify that the model has only changed the to-do. Has only changed the code in the to-do fields. That second part is harder, the first part is easier. So let's finish the template, but let's take a short break first. Thanks for sticking around. All right, we're back. Let's get back straight to coding. So pretty exciting now because we can start a sort of a modular task. Okay, so right jacket right to file. I guess let's write a test project, right? So let's write the test code for the file which we want to populate, okay? And it's gonna be easy because it's all self-contained. It'll be a project. Eek. Interestingly enough, how the heck do I get the language here? More interestingly enough, why the heck do I need the language in the project in the first place? We may have to get rid of this trickery here. Why did I need the language in the project? Let's double check that. Not here. Okay. It's gotta be somewhere though, right? I would not have put that. Yeah, why do I do this? Okay. Not here. Not in what? Self project. Is it to get this in the adapter? Like self.project? Okay, so I get the project in info. I think Why does the project need to be language aware? Yeah, this is a mistake, I think. Oh, is it because of the, wait, is it the, because we wrote the Python one silly, right? Yeah, okay, we're good. We don't need this. Let's nuke this, right? So we don't want this. We don't want, I don't even know why I need this then. Just to pass it here? No, we don't want it. And I don't want you here either. And I also don't want you here. No, here I do want you, sorry. I don't want you... Where do I create the project here? Oh, here. Yeah, I don't need you here. Project only has files. Where are the errors now? Oh, I see. I fat fingered something. So files, just a list of values, return project. I think this is fine. Why the heck did, okay, let's see. Now let's see, we may have to correct some, nah, this looks pretty sane, right? Okay, so how do we run the main thingy here now? Let's remove the output. Let's check if our code works still. So I do uv run -m stream. No. Yes. Stream.main. uv run python -m, or what is it? Why do I not have uv run -m stream.main with args. Files and feedback. Get project structure. Where? Why do I give 3 args? Oh, I slipped the language here. Okay. Very good. So all the changes take effect. Again. Okay, the output file is created. I wonder if we do need that language somewhere. If I just slipped it, oh, good. So we have the output solution, test code, run tests, measure runtime, correctly imported. Yes, from output measurements, runtime import measure runtime. Okay, so let's test the thing now. uv run dash ham output dot test. There we go. Test pass, runtime whatever, peak memory 0 bytes. So good, perfect. Very good simplification. So we don't need the project. Okay, let's go back now to our template. Okay, so what is the template for the PM now? Well, we're gonna make a project with, so when we make a project now, we just need files. Okay, so let's do test files, okay? It's a list of files, and then the project has files equals test files. And then we do, this is the key that we need. We need to run initialize modules. Boom, that's it. If this code works, then, now it's not gonna be strict verification because something, we're gonna get tricked here, because what if the AI decides not to do anything in initialize? So very easy, we'll just assert that the files were written, I can assert that the files were written to disk, but is that idiomatic or not? Maybe I should hide this code from the AI. This opens up a way more general question. Should AI see the test code or not? I would definitely go with more towards no, because we're gonna get tricked here. What if the AI decides to just implement this as pass? This is a valid, and then this can be anything, return banana. This is gonna run, but it doesn't really do anything on disk. We need this to initialize an idiomatic. It has to be something nice though. Should we write another DSPy module that judges the quality? Kinda seems like it, because it's hard to write test code. Interesting problem. I mean, this is basically the problem with AI today, right? So how do you write test code? And do you show the test code to the AI? Let's keep it basic. Let's attempt to just run this. Okay, so what files do we want though? Well, we'll say like this, file. So it's gonna be a list of 2 files, or let's make it 3 files, I guess. First one will have a path, some folder, test. The other file will be some folder inside file. How do we create the files here? We use a dict and then we convert it to a list? Yeah. This is really a crutch here, right? Nah, we can just write this directly. Yeah, it is a crutch, but then let's just write this then. And the third file will be some folder inside meta. This will have depends on, okay, and it'll depend on the, whoops, on the list. Well, we'll have to just recreate these files, but it's fine. It's not the end of the world. You know. Yeah, it looks a bit ugly because you have recreated files. Like we're actually creating new file instances. But this is not really stateful. Like it's fine to have duplicates here. Is it? Let's double check that. So file. Yeah, I think it's fine. Yeah. The only reason why we have this depends on is sort of a crutch to... Yeah, this is fine. Okay, so we have the test file, we have the test project, and we're trying to initialize the modules. Okay, this is fine. And then what else do we need to test? The array. This one is interesting. So test array will be, what does it say here? A list of tuples, and each tuple is a tuple of two lists of integers. Okay, so we can go ham here. So a list of tuples, and each tuple is a pair of lists of integers. Okay, so another one, test, and it has to be jagged too, so different sizes. Now, right, so 1, 7, 1, 1, 2, 16, 23, 2, 4, 3. Then 1, 1, 1 minus 1, 4, 9, 0, 0. And then 5, 6, and 8, 23, 1. That's it. Okay, and then all we have to do is write the array. So write jagged. Okay, this returns none because the write happens in place. So write jagged array to file. We want to write the test array, file name with extension. It's a good thing we put that there, because where the heck are we going to get the file name with extension? Very easy. Aha. With suffix, right? So we're going to say, is a path. Oh, I see. It's a path lib. We're going to need path lib here. Oh, whoops. Sorry. These are all paths. It's kind of annoying, but sure. I guess we can just use an instance from the project, right? Do I actually, so what do I have here? Project.files. Right, so I can just say project.files, the first file dot path there. And actually, let's write it in two places, I guess, right? In one, and let's write it in, well, actually, let's do it this way, sorry. So let's write it everywhere, just so we test it exhaustively. So for file in project.files, just write this array everywhere. File.path. Okay. We don't need this. And that's it. Now we have our thingy here. We really have our template now. There we go. Okay, this is more compact. Okay, so now once AI populates this, we are done. We can execute this. Now, I kind of want to remove this code from the AI. So we get the source and we can delete all the lines from the line which starts with if name equals main onwards. That's a useful primitive, right? So let's see, language. Let's start a new file, utils here. We shouldn't do too much parsing, but I think it's worth it here. Right, because we want to hide. Yeah. So we should hide the code, and this is where we'll also write our unified diff utility. Okay, we're kind of converging there, right? So we need one utility which hides the code. Hides the test code from the AI, because we don't want the AI to take a look at what the test code does and then just say, although the test code will yell if the files are not there. I guess this forces the AI to write files, so we could check that the files exist on disk, because we're forcing the AI to do that anyways. By the way, how we wrote our test. Yeah, that's not the worst thing ever, but Okay, so let's do our first utility. So let's optionally, I'm gonna need AI for this one, because let's see. So remove all lines in string from a matched line onwards. Python. This should be really easy. Yeah, so we just split the lines, partition. Oh, we just do partition, right? So separator, boom, that's it. And we put them back. Okay, trivial then, right? So, oh, it's actually a fundamental. I didn't even know this. So then we need a core function, which will be remove split code, right? This is so easy, actually. It's just a string, and then it returns. What does this return? I guess it's a list of strings, I wonder. Well, sorry. So the code and the separator. So then we just say what? Oh, it's just a tuple of strings. Well, this is the easiest function ever. Like, it's literally just return code dot partition separator. Okay, this is it. So now we can separate based on we know exactly what the test line is. This is universal, right? Oh, what do we do here? Oh, we don't need a file adapter. Good. Let's see. So code. So the template will be, first it'll be this. And if we want to separate, well, let's just separate for now, right? Because we can say like this. Code. I'm sorry. So from stream.language.utils import split code, and this is going to be split code template, and the separator will be, it's got to be exactly this line. It has to be this. This is a universal thing in Python. There we go. And then we just feed the template here. All right, let's run this then. We are ready now for the first time to run this. Okay, UVX, utils, good. So then we go uv run -m stream dot language dot pm with what args? Language Python is okay. Feedback, I guess. Without feedback, we'll see what happens. Oh, did I slip a string? Oh, sorry. Oh, here we go. It's a file. This path is a path. Okay. Ah. Oh, okay. We are. Oh, I see. Interesting. Expected 3. What? Blocks? What blocks do I get from this guy? Blocks? 0. Okay, this is the... Right, this is the code all the way up to main. Ah, okay. It's the line and onwards. Well, this is not the greatest, because then if that line doesn't do anything... Is there a way to get before? How do we do? Is there an ellipsis like ... I think this works in Python, right? Template and everything else? No. I gotta do it like this, then I have to split 3 ways. By the way, our completed PM has initialized and now it's empty because it did overwrite this file, which is good. Our file management system works. Okay, we're done. So inputs, trivial. I don't even need the project input actually, sorry. Let's see what this module predicts now with execution, but without strict template verification. But we're very close to finishing this actually. We just have to implement the unified diff functionality, but it'll have to be done inside the module with code feedback, right? So here we'll have another arg which will be strict templating equals true. So that's a big functionality, and I think we can add it in like half. Okay, we're done. So we have a pred now. And not only that, this should have been written to file. Oh, it wasn't? Why? Did I not ask for feedback? Yes, I didn't ask for feedback. That's why. -- feedback, very important. Actually, I don't even need this then. Sorry, I don't need the breakpoint. Technically, although we should have kept it. So I just run with feedback and then I observe what the PM file is written to disk. And I know if, well, I don't know if it's successful. We should write the DSPy history, by the way, but there we go. Okay, it did not, the most annoying thing is that I see, so we're in Python, so then it just followed my instructions. Aha, there is an issue though, because we need to, when we attempt to execute, It used Python repr here. Interesting. Which is correct. Eval repr object. Very nice. Now, okay, we're done. So this code works. The problem is the main code is not glued to it. Interesting. Let's think about how we get that there. Let's store the history before that. So what should we do here? So how are we gonna, okay, sorry. So let's do this thing here. Save the original standard output. We'll write the history. We're just gonna write it to history PM in this case, but history PM. Okay, this is all good, nice and fine. Let's write it again. Let's see what the PM outputs. What I don't like is that for Python, this is kind of cheating because there are instructions in the template that tell it exactly what to do for Python. Oh, here it decided to remove the comments. Yeah, these are correctly. Sometimes it does use the variable name is found in with extension stem plus data. Okay, very good. I was gonna say this, but, okay, this is good. So then the thing is, if I now run, this is gonna run, but, right, because I can do stream.language.completed.pm. It runs, but it runs because there's no main. But at least, okay, so this is actually not a bad first check because this tells me all the code that was written was valid. But we want even more than that. We want to test this code. What I need to do for that though, the thing that's running the code is this module with code feedback, okay? So let's have this guy be aware of some test code equals none. And the logic inside will be that, so test code will be string or none. And when this guy sees test code, he's gonna store the test code first of all, okay? He's not gonna do anything to it, but right before he runs, he's gonna append the test code which is Python code, by the way, right? Because this is all Python world here. So this works pretty nice because this allows us... Yeah, so we're in Python metacode land now, but this is fine. This is where we want to be. That's the whole point. So then where the heck is the execution? It's very simple. It is... Aha, here it is. Execute code. But it's from Python, right? Yes. So this guy we don't need all this extra junk actually, because we need to deviate from the temp, because the Python is special, right? Yeah, let's do it this way. So the Python will not have any of this optional crap. That's one change, but let's not do it here then. Let's just leave the execute be pure. where we want to do, what we would like to do is right here. Where do we write it to file? Aha, here it is, write code. This is what we need. Damn it, we wrote this too generic because so it takes a prediction. So this may be in a language or another. And it looks at all the code outputs. Is this also a templated thing or not? It's not. So do we want this to have extra code? Let's see, what does Python do if you do, I think this maybe is it. So we have a string, a equals hello, and we do -n dot join the list of a and none. Nuh-uh, it has to be an empty string, right? Okay. I guess we can take the code from here, okay? Pred name dot code, and we say if extra, we do -- nn dot code will be joined by extra string or none, and then we just write this code. Okay, if extra else pred, we can just do this in line, it's much cleaner. Right, so if there's an extra when I want to write, but the thing is this will apply to all fields. Ay, 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 ay. Okay, sure. So extra name, right? So it's a dictive string to string or none. I think this works, right? So extra for each field, if extra name, if extra get name, right? So attempt to look in this dictionary if extra and extra get name. So if this is a valid dictionary and it has that key, append that extra to exactly the field in the signature, in the prediction, good, yep, which is the field in the signature, else just do what you used to do. Perfect. So now we can, we just have to pass this. And I believe this logic works. Let's test it. So we can do something like this. So A equals none, B equals sum 1. And we can say C is 23 if A and A dot get sum stuff else 46. C should be 46. Okay, so this didn't crash because the if A, good, triggers an early exit. And then we can also say C is 23 if B and B get stuff else 46. This is also 46. And then finally we can say get sum. This is 23. Okay, so we know Python. So that's good. This, now I can finally go back here. And I can say extra is self.test code. Now test code has now become a dict string. Okay. And finally, we can go back to what we actually feed here is, so what is the test code? Well, oh, sorry. It's a dict and it has one key in this case. PM is right, so it's -n dot join statement and test in this case. So I take these other two thingies and I join them together, and then inside the code execution this gets joined with and this is what also gets written to file, right? Because, and this permanently stays here, by the way. Like, this is the thing we write. I don't think, do we write our own code here? No, we don't write our code. Nope, we rely on the AI inside the feedback loop. So wait a second. So if I run without feedback, then what happens? Now I understand why. Okay, now I get a lot of stuff. Now I understand the mystery we had before where we were making some changes, but it seemed like the code was broken and shouldn't run, but then it was still running. That's because if I disable the feedback flag, I'm actually not writing anything. So this is, we should just nuke this then. Okay, so this is another simplification. You know what? We don't need this anymore, because if I run without feedback, I'm in big trouble now, actually. Because nothing gets written to file, so that's not gonna fly at all. Good. So there is no more feedback flag. All right, let's start pushing some changes because we did a lot of stuff here. Oh yeah, we need to change our git ignore a bit. Let's see. So not only history, but history star.txt. Good. So git add git ignore. Shim. Update ignore. Good. What else? Git diff src stream main. Simplifications. So git commit -m simplifications. src stream main. And well, this was a bad commit because I think we also changed, we changed a bunch of stuff. The project, right? src stream project. Yeah, we changed a lot of stuff. Oh, no, that's correct. Yeah. So then we want to commit this. Support extra in write code. What else did we do? What did we change in feedback? Write test code in feedback loop. Okay, what else did we do? Well, we just have to add everything now. Stream language completed, Python git remove src stream language generate And what else did we remove? Template. And we're just gonna add the dot. Add project manager functionality. That's it. Okay, so we are live here. What did this code do? Nothing. It didn't finish. Oh, I see. So let's run the code then. Let's run the PM again. So uv run stream dot language dot PM. The PM doesn't need feedback anymore. Another mistake we need to clarify, because it's always with feedback, right? Cannot mess with that. Right, so this should just go away. Okay, statement test. Let's see. Stream. Language.pm. Oh, sorry, it's uv run -m module. Sorry. Okay, what? This should be basic. Oh, I'm sorry, it's predname.code, right? Because we want to join that, obviously. This is a big bug we fixed. Let's try again now. Did I mess with execute code then, or what's happening here? Oh, I did mess with execute code. Ah, then I do need this back. Even though the Python completed one doesn't do anything with it. Yeah. Right, because we want to, but what kind of code does this execute? Yeah, no, we need this. This will be generic. Where is this Python land? Let's leave it like this. There is a problem here because I kind of assume that this is Python land. So what, we're gonna have to write another DSPy module with feedback, but for arbitrary languages now? No, you would hope. Nah, this is why we wrote this like this, right? Yeah, this should be a language agnostic. It is, but oh, damn it. So we're gonna have to, I see, we're gonna have to monkey patch these to be imported from whatever, from the completed.pm file. Okay, maybe it's not too bad. Yeah, monkey patching is easy. Okay, so I need to write this down. So monkey patch written PM files into stream.feedback, because we're gonna need that at some point. Yes, I'm pretty sure there's no way around that. Unless we write another, I mean, there's no point in writing another DSPy module. Why? Just because of 2 import lines? Right. So, because I know we took care of this last time. So this project is generic. There's nothing here about Python, actually. This whole module is generic. The only thing about Python is this string here. If I replace this with PM, now I imported whatever my AI wrote. So then it's easy, right? We'll just monkey patch these in. You can in Python, you can dynamically replace these imports at runtime. Pretty easy. It's like 1 line to replace 1 import. So with 2 lines of code, we can have this use the AI generated code and then plug that into main, right? Because this guy uses code feedback, but he uses it in a language, right? Yeah. Okay, so yeah, we're putting this back in Python, execute code, all good. Status, -m bug fix. Okay, we attempt to execute again, stream language PM, and we should see something aha, oh, we already saw something completed. Well, there we go. Oh, and we know it runs now. No, we don't, because we never made it past the execute. We'll have to see now if it runs. But remember, we need the unified diff, which is a big functionality. This is taking a while, sign that the AI is trying to execute this maybe and something is busted. Why would it be? Because test files are some folder test. Aha, so it created some folder. Oh, good. But wait. No, my bad. I need to create these because this initializes modules. Let's see. Initialize modules, write jagged array to file. Template. Aha, so now we have the attempts. The previous attempts, the outcome. What is the outcome? I'm so dumb. So in line 80, of the PM. Okay, well, this is really, of course, test project dot files. So can I, if I write, yeah, this should populate the file. Okay, my bad. So so because of this main code that was broken, the Python code was always returning an error. Perfect, good. So let's have this be like output meta. Sorry, it'll be sum and it'll be replaced with output meta, right? Because we are now pretty good. Okay, now I'm 100% sure this should work and it should actually execute quite fast because this should actually, so this initializes all the subfolders and this one writes all the files and we are done. Of course, assuming the PM wrote nice code in the completed PM here. Okay, so it figured out to do the... Now I'm curious if did it ever see an error? Let's see, outcome. Oh, suffix self string, unexpected indent. Okay, so then it tried again. Aha, then it figured out no such file or directory. And that's it, then it fixed it because it figured out, oh wait, I also need to create the files and directories. But what happened to my extension though? Whoopsie. Almost, but why? Why no extensions to files? How does my test code look like? Ah, because I forgot. With suffix. Here's my problem now. Because what suffix do I write here? This is with suffix. Check this out. It's a test project.suffix, right? Yup. Because, yup, this is what I forgot. Again, yup, we're done now. This is actually amazing. Okay, so the meta code works. So now we can generate code that when executed writes a complex project structure to file and also writes jagged arrays to file in a given language. Now, of course, the trick here is that we're running in Python. The real test is if we run this now in Rust, will it generate .rs files? And I think it should figure out that it's .rs. Now it's easy, and I should initialize a cargo crate and that's it. Pretty modular. So while this guy is working, and it is working, we can start looking at... Is it working? Come on. What happened here? Why no? Why not? Why? Outcome? It deleted the code it wrote. Good. So now we have a problem now because the AI mistook indentation. Aha. Okay, this is another very good. This is it doesn't work because of an issue that is very subtle, but it like throws the AI completely off balance. Notice what it did here. Well, first of all, it moved all these methods in the file class, which is completely wrong. It doesn't know that because it didn't see the test code, which is intentional. Had it seen the test code, it would have figured out, oh wait, initialize modules actually has to be a method of the project. But that's not how we're gonna solve it, okay? We're gonna solve this with strict templating. It's exactly what I was talking about earlier, because we wanna make sure the AI only modifies the code only inside and at this indentation level. So the AI should never get a chance to move this here, or not even touch one letter here. Like if this SS suffix, wrong. Okay, so for that, let's leave this, remember this failed attempt. And we're gonna use a library called unified diff. And we're just gonna write an utility function that takes as input the template and the output solution. And look at where the code differs, and if it's anywhere else that's not glued to the to-do, that's a rejection. We're gonna have to be a bit careful. We'll need some tests here. So import unidiff, is it? Is it unified diff? What is the name of the thing in Python? So Python unified diff. Oh, difflib. Okay, gotcha. So import difflib. Okay, good. That's it. So we're gonna write compare with template. Okay, so it takes as input code and template, and it will take as input also a marker which tells it where are modifications allowed. So allowed change. In this case, allowed change will be the string that we put here to do populate this. Okay, so this is fair game to change, and anything at this scope is also fair game to change. We'll have to be very careful how we quantify this scope, because this is also a continuous block change. This is gonna be pretty nasty actually. But we know this is Python, so we can leverage indentation level. I think that's the only way to do it, right? So at this scope, you can change a continuous block after this until as long as you keep the indentation level at least the same, okay? If you attempt to change this line here, which is outwardly indented, that should be a reject. Otherwise, you're allowed for each to do, you are allowed to make one contiguous change. You can add as many lines as you want here, right? At this indentation level, like If you try to do something this, you're done. You fail. You can also do inner indentation levels, right? Inner is fair game in Python because we stay here. Yeah, this is it. And so we're gonna have to write this for Python. It's now, of course, if you've been following the series, you can instantly figure out a meta module, which will write this for arbitrary languages, because I would like to template Rust files, or I would like to template anything dynamically, and that templating will be applied to this project manager, which the project manager is applied to problem solver. So now I've turned this into a meta code problem, but we can leave that for another time, which is not a bad idea actually, how to write templating code for an arbitrary language. But for now, let's write this for Python, okay? And we're gonna return a Boolean, okay? So if it's true, then validate with template. Okay, so if it's true, it's valid. So is valid true, return is valid. Okay, anytime we detect an outgoing change, unallowed change, we'll flip that to false. Now, we're gonna need to play around here a bit because I have never played around with this. So if the name is main, let's mess around with difflib. Difflib can be quite tricky. Let's try to do this. So is there an example here? There are many examples, right? I wish they wouldn't do this though. Compare A and B, list of strings, returns the delta in context. So we want to do this split lines. There's another trick in Python though, because you can split lines and you can move the indentation level to the left. Wowie. So that'll get rejected, right? So what I'm thinking is, what if I have string A? We're gonna write Python code inside these thingies now. So it'll be like def sum fn okay, args, and it'll have the magic thingy called TODO populate this, okay, and it'll have ellipsis, and then let's say B is our, so we're gonna write some test code for this, okay, and let's say there's also some function before this, other fn args return false, okay, and let's say there's also some function after this which reads class more stuff, and it has define init, and it has self.a equals 1. So now we would like, and let's say this one has a method too, method self, okay, to do populate this, and this guy has another method, do not touch self return false. Okay, so now let's say B is a populated, B is going to be exactly the same thing, except we're going to put something in there. So let's say we do A equals 12, return A. How the heck how do I get the diff between these A and B now? Well, we're gonna have to read the docs for this. Diff lib. Sequence matcher. What the heck is a sequence matcher? A, B. Option argument must be none, or one argument function takes sequence of truth to elements is junk, passing none for each junk equal lambda x false, none elements are ignored. Sequence matcher gets 3. B junk is elements for B as junk is for which B junk is true. B popular. Oh my god. Set the two sequences be compared. Find get opcodes. Ah, okay, it's an opcode thing, which tells you from line I1 to I, or from, damn. Okay, there's an example here. So I have these two strings and I do sequence matcher none AB. I see, so it tells me I delete Q, and then it's equal from 1 to 3, that's correct. Well, it gives you the indices. And then X gets replaced with Y, it's equal CD, and then it's insert F. Okay, so what do we have to do? We have to split this in lines. What if we just try to do a sequence matcher directly then? Yeah, let's just do it. So I go what? S. Oh, I'm just gonna take this code then and print it here. Let's see. Okay, pretty good. This is pretty clean, I guess. So one option is we could do split lines. So is it difflib.sequencematcher? What is happening here? Yes. Okay, so now I can just run Python, no, -m. I can just run the main from this guy, right? Which is stream.language. I believe it's utils, right? Yes. Whoops. Utils. Right, so the first 87 lines are equal. The first 87 characters are equal, which makes sense. Then I have an insert of A12 return A. Why do I have an insert of define of class stuff too? And why do I replace? Wow. What? I don't know what the heck is going on. This doesn't look like the right thing. Because I think the AM... What? Where is A? Oh, I see. So print A and print B. Okay, I get that I inserted lines, but why is everything else not identical after this insert? That's my question, right? Well, oh yeah, no, this should be identical because I didn't touch the second populate this. What the heck? All right, let's see. I think we're gonna take a quick break here because we're gonna have to let me try it quick on split lines, which is a list of lines. I don't think this is gonna work. Oh, sorry, split lines. Don't think it works this way. It does work this way. What? Oh, I see, because it's not, no, this is made for strings, right? Yeah, because it reaches into the string there. So it has to be like this. My only question is, why the heck is it? Are these strings not formatted default or something? Or do I have weird characters here? I really shouldn't, because I just typed... Is it like a new line thing? Is it the strip? The insert I get, well, no, I don't even get the insert. Oh no, the equal I get. The insert I also get. So nothing becomes A12, return A. Something weird is happening here because it's seeing that I... So at A87 I insert this. Okay, then I have, it goes all the way to the dot. Though. Ah, this dot here. Wow, this is so bad because this is this dot here gets matched to the dot there. Wow. Definitely don't want this. Yeah, we need line by line comparison. Yeah. So raw strings in Python is going to be a disaster because it sees the dot here and it says, oh, you know what this guy did? He reinserted this stuff, but then I'm going to resume this dot from this dot and they'll be equal, but then... Yeah, it's a mess, right? This ain't gonna work like we think it will. Yeah, so we need line by line comparison. I think that's actually funny enough. That should be easier. Yes, I'm pretty sure. Actually, we should just get the opcodes. I'm almost tempted to do this by hand, but nah, we want to use this, right? Like it's a 2-pointer thing. If you go line by line. Right, so we would have to go line by line and keep track of the indentation, and that's it. And as soon as we hit the to-do block, we allow a change, and then once we exit the to-do block, we disallow changes, and we keep comparing lines. I think that's it. The only caveat is that Python allows splitting strings and shifting the indentation level to the left. I don't think there's, not even unified diff can. Actually, I'm not sure how unified diff will handle the indentation in the first place. I think we will have to go line by line ourselves. We need a unified diff for Python specifically. Diff lib for Python changes. Let's ask Gemini a bit. Because something is a bit fishy here. So we can say like, I'm trying to use diff lib to compare two strings representing Python code with various data structures, functions, and indentation levels. I would like to detect that all the diffs in B happened at a certain allowed indentation level in A. Is there a clean idiomatic way of doing this? Let's see. But because difflib generally doesn't understand that, that's exactly my concern. It doesn't understand Python indentation levels natively. To do this clean, you need to combine difflib differ with a custom filter that inspects the prefix tags generated by the tool. Because we're still, but it's still making the assumption that compare which marks changes and check white space count of the original line. Yeah. So verify at indent, string A, string allowed indent. Differ, compare, split lines, split lines. Okay, so this is what we're about to do too. So you compare the lines with differ. We only care about lines that were added or removed. This line starts with, well, yes. Yeah, this should be good enough because then I can return the indentation level. I can extract the indentation level from the reference. This is good. But there is a caveat. There exists Python code that such as increasing it. This one is easy and should be allowed. And should be easy to just check for allowed or greater than indentation, such as defining an internal function. Decreasing it. This one is trickier, like when splitting an F string or triple quoted string across two rows. How would I handle this? Yeah, Python is not aligned to have decreased indentation. Without your logic, you need to differentiate between struct. Yeah, so we have to parse the Python code. Tokenize module knows exactly when the line is inside the string. Okay, pretty good. Wow. So instead of looking at the white space, we can pre-process the code to identify which lines are safe and which are content. So tokenize returns a set of line numbers that are part of a multi-line string. So he solves this one manually. Is there a more generic solution? No, we don't want to No, there shouldn't be any error for tokenized string. Verify smart indent. Content orientation doesn't matter. Check with the line close bracket. Python ignores indentation rules inside these. However, this is prone to errors. Yeah. No. No, I don't want you to do that. No, this is good. The other thing is I won't specify the min indent by hand. Instead, it should be detected from marker comments, lines reading to do in the first string. Once such a marker is encountered, any subsequent block that is different in the second string should respect indentation. Yeah, so we see to do, we capture the indentation of that specific line. Toggle check mode. Once the marker starts validating changes. I think this is how we do it. Don't like this tokenized thing. Oh, sorry, I messed this up. You might want to check for to-do reference. Once the to-do is found, it replaces the entire rest of the file. If you only want to reply block immediately, you can modify the script. Yes, this is what we need. Yes, do that. Because we have multiple to-do blocks too. I mean, there's like 27 nested ifs here. What the heck is happening here? If marker indent is not none and is not empty. Oh my God. Yeah, this is kind of what we want, kind of. So this is interesting. I think this minimal diff is what we encountered here. Function is differ. Okay, so this split line keep ends true. Differ. So can I get All right, we're gonna have to take a quick break. Still not 100% clear what's happening here. We're definitely gonna have to sequence match lines or differ lines. So let's start with this basic one then, right? Maybe the strings we can leave. I think this is way too complicated though. I mean the subsequent logic. So maybe what we just need is, yeah, we definitely need the lines, right? So the lines in A, and we now have a diff. This one is not good because it's raw strings. Let's see how this diff list looks like. Okay, so diff. What is this? Ah, come on. Diffs for diffs and diff. So, oh, these are actually just strings minus plus. Oh, this is good, right? So let's see. So I find the to-do. Either I find the to-do, or here's another difference. What if the AI leaves the comment, removes the comment, right? Self dot b equals 1. Let's see how this one looks like. Yes. So we're gonna say, what do we say here? Print d for d in diff. Yep, okay. I think this is way easier actually. So the state is like this. Either I find the line that's the to-do and I start allowing changes where the minus and the pluses have to be at the same indentation level. And for that, I just replace the minus and plus, or I count the spaces and add 1. Okay. Right? Yeah, because this is the... Oh, no. Actually, I just count the... wait. No, I do add +1 because for some reason this has how many? What the heck is happening here? So, diff of 3? No, 4? 5? Right, so how many spaces are there? 1, 2... There are 4 spaces in here. Oh, 5? 5 spaces. What the heck, dude? How many spaces are there in here? Oh, yes. No. Why 5 spaces? Oh, come on. Is it because it's adding... I guess there's a magic +2 from somewhere. So I get an indentation level of 6. Why do I have... Oh no. Why does some FN have... Is this a thing where this function adds 2 spaces in front? It must be, right? 2? Yep, 2-letter code. There we go. Okay. Right, so I have a static 2. Okay, so then I can always... What would I get the question mark? Lines beginning attempt to guide the eye to intra line. Yeah, we should not get a question mark. Okay, so the line should either be common, and then what I want to see is, I need to see a continuous block of minuses and pluses. And if I strip those, the indentation level should be the same as the line I found with the to-do. That's case one. But the AI may also decide to... So here's the thing. The AI may decide that he wants to delete the to-do, which we should allow here, right? So then what I also need to do is I'll look at not only if I find the to-do line, but if I find the to-do line and I don't have a streak. So when the streak starts, either to-do line is the first line in the streak or the line before. Yup, that's it. And then I just, from this line onwards, I count the streak, and it must, the indentation spaces must be at least whatever this line was, either this or this, which don't matter because I subtract 2 spaces from each one, yes. Okay, and then that's it. Once the streak ends, I'm back to reset. It's all fair game. Now, yeah, this is it. And this is a single string, right? So I don't have to struggle with walking 2 pointers. Okay. And then I can, this is how we tightly control AI for Python code. Because now I can explicitly tell, or I can reject the output, and we're gonna have to write some natural language feedback for DSPy, like, hey, you violated this indentation. Please respect indentation levels. But that's easy because we will add custom messages to our module with feedback we wrote last time. So then that'll be the outcome. If you remember that those dynamic fields we had, will warp the outcome a bit. Okay, I think we can do this pretty quick, at least the unified div part and then the DSPy integration. So we'll take a short break. All right, we're back. Sorry for the long break. And okay, so let's do this difflib thing. So this looks pretty good. So what we want to do now is we would like to say something like, so we get the difference between lines. Okay, and then we start. Okay, so streak is false. So we start without the streak, and then we say for and also we're gonna start I'm curious, what is the diff between, let's see, so list, d compare, ABC, and ABC. Aha, so be careful here because we're gonna need changed blocks. We should keep track of how many blocks were changed because we want to say something like, if changed blocks less than expected blocks, we're gonna tell the AI, you did not implement all the functions, all the requested changes. There is a trickery the AI can do here because they can just choose not to change anything. So that's gonna pass our logic because we're only gonna see stuff like this, you know. So the overhead is 2, okay? So we know it adds 2 spaces. And we start with a valid streak, and then we're gonna say for diff in diffs, okay? Okay. If the first 2 characters are space, and I'm not in a streak, continue. We're done, right? So this means I'm not in a streak. But wait, I could hit the to-do block actually. Sorry. Ooh, yay. Okay, so what if I strip this? So D. Oh. Okay, so XX equals, so XX 0 dot strip. Okay, so if I have a thing, and if I strip it, and the prefix is to do, is there a why? Oh, I see. And I'm not in a streak, then I just started a streak. Now, how the heck do I find if a string starts with another string in Python? This should be really easy, right? Determine Python string determine if starts with prefix. If a prefix in a string starts with. Okay, perfect. So if the strip difference starts with to do, that's good. More general, it'll be my marker phrase. And I'm not in a streak. Then I start the streak. We start a streak and expect only, so we start the streak, capture the indentation level, and capture the indentation level. Okay, so let's see, indent level. So it's 0, it's main, right? Is now Okay, Python count number of leading spaces in string. Strip from the left. Okay, so there we go. Length of, now which, remember we have to strip this, sorry. Okay, so let's do it this way. Marker, type, and no, div type and div code. Okay, so this is gonna be the first two and this is gonna be the second two. This is always true for this. So if the type is this, and I might as well strip the code, then I look at the length of the code minus the code stripped, and this is my indentation level. Okay, so this is also an int. I'm just gonna write it in main so we test it easier. Overhead I do not need anymore. This is universal, valid, boolean, sure, true. Okay, so diff code strip started with to do, and I'm not in the streak. We started streak and captured the indentation level. And of course streak is true. Which we should have said like this. And then what? Do I do control flow here? I guess I do continue, right? Because I'm done with this line. Because I know I found the to do. Change lines in block 0. I guess I can set this one too. Okay, I guess we'll do it this way. We'll do not, let's not do control flow, right? So else. What other cases do I have? If the div type is this, and what's the other way to start the streak? I should just do it here then, right? Or true, or I guess, or false. The other way is the div type is negative. It has to be only this, right? Well, actually, it's only this then. This is more compact. So it could be either equal or negative, and that's it. Pretty clean, right? Yes. All right, so it's either equal or negative, and the code is what's after, starts with to do. After stripping, and we're not in the streak. Okay, so now we know we found the streak. The other case is this is nothing. So if it's a div type, and if it's not a div type, and the code doesn't start with to do, and we're not in a streak, nothing. Okay? But there's another option. What if we just We are in a streak. Okay, so we find two identical lines. I guess as a user, should I... So there is another trickery here, because if I leave... What if I leave stuff like this? To do populate this. To do use what you populated. Aha, be careful here. Because let's see, so if the AI... I start a streak here, but then I'm gonna hit the to do, but I'll already be in a streak. Which is kind of fine though, because I stay at the same indentation level, right? So I don't really need to check for this second to do. Yeah, no, this is fine. So once I'm in a streak, okay. But okay, so now if I hit the same line, and I'm not, but I was in a streak. As long as it's, there is a trickery here because it's also not a to-do line. I think this means the streak is invariably over, right? So I can count this block as changed. And that's it. Okay, else, this is the big one. If I am in a, if the div type is either div type in minus or plus, actually I can use this in here too because it's cleaner. So if the div type is in neutral or minus, okay. Now if the div type is, if this is a changed line and I'm in a streak, well actually wait. No, that's it. If this is a changed line. Well, no. If it's in a changed line and I'm not in a streak, something somewhere else was modified because I never marked the start. I never exited gracefully because I would have caught this, right? So, okay. So, and not streak. This is an invalid change, right? Because I would have caught... All the streaks should start with this. The to-do should either stay there or be deleted as the first thing. There's no other way around that because I only want the AI to change code after that to-do, right? Good. So we know we're past this. We know we're not here. We're not here. We know we do have a change, either a minus or a plus. But we know we weren't in a streak, so it happened somewhere else. Valid is false. Break. We're done. Maybe feedback. You did something wrong. Okay, so we also have a feedback. str none is none. Okay? And then we return feedback. Okay, else if, what else? Div type in these guys and streak. So I know I'm in a streak and I have a changed line. Now I have to verify the indentation. Okay, so we say indent level this should be a none because it has to be set. Yeah, we don't care about setting the indent level for same lines. We shouldn't actually. So ref indent level indent allowed. Okay, so we have this. If not, no, this should be explicit. If is none, we should raise a value error. Something went wrong because this should always be set here, right? Yeah. The indent level should always be set in a streak. That means we made it, this is good to debug our algorithm, but okay, otherwise, assuming this is set, we're gonna get indent current, which is, it's exactly this one. It's the same thing. Okay, and we're gonna say if indent current is less than indent allowed, valid false, feedback you did something wrong, break. We're done here too. We can destroy all execution. Are there cases that we missed, or is it just these 5? Well, because we should have 8 cases, right? Not really, we should have 4. These 2 are 1. So these are non-streak. I have 2 effective for non-streak and 2. Yeah, so this is 1. Okay, I think this is it. Okay, let's test this out then. We just take all this and we're just gonna have this be our function then. Right, yup. We are going to do validate with template. Okay. Yes, so lines code, lines template, code, template. Starts with allowed change, lines code, lines template, change the lines in block, return a valid feedback. So this returns a tuple of bool and string. What else does it do? Change lines in block. We forgot to count this. Yeah, we forgot to count this here, right? So if we survive this, Doesn't do anything though. Changed blocks if div type and not, and we were in a streak and doesn't start with to do, we end the streak. Okay. There is one last thing though. If it's the last line, yeah, maybe we don't need these. Let's strip all these then. I don't like this. So streak false, changed lines in block. Whoops. Changed lines in block. Okay. So we got 5. Okay, so we start with the allowed change. Okay, and then we get, what do we get? We get valid feedback equals validate with template. A, B, allowed change is to do. That's it. Because it just needs to be the prefix. We don't care. It doesn't have to be semicolon and everything. I'm not sure. Let's see what's happening here. Looks okay-ish. UVX raw format. Okay, so we formatted our thing here. Pretty nice. Yeah, this looks pretty clean. So, well, not... we just gotta make sure we have coverage on all the branches of the logic. Yeah, feedback, indent allowed, and the streak marker. Okay, so let's see. So if I do uv-run stream language utils, okay, it executed, so nothing weird. Valid false. Eek, eek, eek. Why? See, because because it's a complicated case. Okay, so this is kind of good then. Yes, maybe we should use pytest. I'll bet you this is true. Yeah, okay. So this one is true, but actually we kind of hit the complicated case already. Why does this not work? Let's just view the diffs then. This should be easy to tell just from the diffs. In this case. Because we missed one pattern probably. So print D for D in diffs. So let's see, the logic is, so first we blah, 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 we hit this line, okay? We hit this break, we hit this, not streak. Streak is true, indent allowed is 4. All done. Well, actually, let's debug that way then. Okay, so continue. Okay, indent allowed 4. We know where we are, right? We are diff, good. Next. The next diff is A12 with a plus. And it hits, do we have a streak? We have a streak open. So it hits this last. Indent allowed is 4. Okay, so let's see. No, it's not this. No. No. Yes. Indent allowed is not none. We pass. Indent current. It's a 4. It's not less. We're good. We pass. The next diff. Return A. Same story. It's a plus with the streak. Is it none? No. Is it current? Yes. It's still 4. Okay, the next line. Minus dots. We're still good. It's a minus. We're still inside the streak. Next line. Why just a minus? a new line. Wow, this is so brutal. So the model modified a new line here. Yeah, I see what's happening. I get what's happening. So, print D for D in diffs. So this new line here that got deleted, well, I'm pretending we're the model, but because let's say the model decides to do this, right? Populate, and for the use, they do this, but they eat the new line. So we should allow deleting new lines inside the streak, because what's gonna happen now, so the diff type is a minus, but this is gonna fail, pass, indent current will be 0, valid false, early break. So what we need to do is we need to allow so if it's a minus, let's just allow it here. Should we do nested logic or special case of new lines added or removed, right? So if we say that, yeah, I think this is fine. So we know it's a plus minus, we know we're in a streak, so we can say if diff code.strip is blank. Well, okay, this should survive. Then we can continue, right? We're allowed to continue. Well, okay, I guess we'll get the indent current. New lines are always valid. So we'll just say indent is indent allowed if diff code strip, else this. Yeah, I don't think there's a cleaner way to do this inside the streak. Yeah, because the model can just decide, hey, I'm gonna add 2 new lines just to make the code cleaner, which is actually, you want that. Yeah, so then we can just allow this. Check for indenting. Again, this is not gonna work in, well, it kind of will work in, well, it's not gonna work in programming languages that don't have indentation, which I don't know that many, to be honest. But for now, it's fine. Good. So we got this. Let's remove the breakpoint. We can remove this. Let's try again with the more complicated case. And I think this should nail it. uv-run utils. Where am I? Valid? True. Pretty good. Let's make a false one by intentional, right? Let's make a C, which starts as valid, but also does other fn, well, somewhere. Do not touched. So then if I go and I do C, do I not have C? I do not have C. Let's test the new lines more then. What if this guy decides to add another new line? What if he decides to add a new line outside of a streak? Interestingly enough, that should also be a fail. Like a new line here is a fail, right? Yes. I think this is fair game though. Like, why would you do not touch this? Like, I don't care, dude. There we go. True, false. Because I intentionally do not touch it. What if the model decides to add more code? Add more code. Or let's say define added. Sorry. Added self and pass. This should also fail. Yep. I think we're pretty good then. Let me quickly look at pytests then, because I kind of want to systematize this. Okay, so let's write some pytests. This is the first time we'll need some pytests because we want to test this code, right? Okay. We gotta learn a bit about pytest because I'm forgetting how it's done. I guess we can do them right. Oh no, it should be in test. Okay, sure. So thank God we have UV, because I can just do UV add pytest. We're done. Okay. What is UV is yanked? UV sync. UV cache clean. UV is very disk heavy or cache heavy. That's the only disadvantage I know. Oh, I didn't do my daily harping on UV, sorry. Yeah, it sucked up like gigabytes. It's fine. Okay, so we added pytest, done. I believe the way it works is you have to create a new folder. Test? I don't know. Let's see. pytest version. Create a new file called test sample. The test. pytest will run all files to form test and its subdirectories. Standard test discovery rules. Oh, come on. Just tell me where to do it, dude. Tests. Okay. Tests outside application code. And inside? Nah, we want them outside, right? Yeah. src my package init. src my package init. Okay, so then this is pretty clear. So we just make a tests. That's it. And we do a new file. Test. Templates.py. And we go import pytest. Do we even need to import pytest? Doubt it. We don't need to import pytest. We just need we're just gonna do this thing in strings then. Test matching. And what? No args, right? Yeah, let's do a basic one for now. So then we're gonna say from, we don't need this, from stream.language.utils import, what do we call it? Hello, language, autocomplete dictionary. No. Validate with template. Okay. Test, validate with template. And test valid with template, test invalid with template. I guess we can just call this at, should I do this, or maybe this is not good practice, right? Func. How do I fixtures? Do I want the fixture? I want a variable. Oh, yeah. Oh, this is way too complicated. How to parameterize. They have a typo here. How to write, how to invoke, how to mark test functionality, how to use subtests, how to parameterize fiction and test functions. Like, I need something more basic. How do I just organize a variable? Am I supposed to write it? No, this is too easy. Test fruit salad requests fruit bowl. And when pytest will execute the fruit bowl fixture function and pass the object it returns as the argument. Requests. Okay, so then I can just return the string. Okay, so then we'll do it this way. So then we'll have a fixture. And we'll do a pytest.fixture. And we're gonna call this original code. And it returns str, and it'll just return this thingy here. No, this will be the template, right? Okay, so this will take template str, and it'll take valid str and invalid str. There's got to be a way to parameterize this. This looks like a very common thing. And then we'll call valid feedback is validate with template, valid template, allowed change, which is also here. Oh boy. I guess we'll have to do exactly the same thing, except here we're gonna assert valid is true and assert feedback is none. And here we're gonna assert valid is false, and we're going to assert feedback is something that I don't know what yet. Now this, let's see, what was it? Okay, so we can actually chop this off from here, and we can return spam dot strip. Nice. And then we'll have another fixture, which is, do I need to, is this a decorator? No, it's just by dot fixture. B is the valid one. You go, so this, oh sorry, define valid str, return, perfect. And oh no, wait, do I have to shift tab this? No, I do not have to shift tab it. It is shift tab. And we have another fixture. Man, I should really keep these in files, right? It's fine. Invalid which also returns an str, in this case, C. Ah, sorry. C. Oh, with the strip too, right? Yes. Oh, come on. And these guys are toast. I don't need the main here at all. Okay, so I returned 3 things, and then I also need this allowed change, which is another fixture which kind of dominates everything. Allowed change, str, return. In this case, it is TODO. Okay, that's it. UVX rough format. Okay, we have the fixtures, everything. Okay, whoops. UV sync. Okay, why did I have to do rough? I don't know. Oh, it's because it UVX was eating from the cache, or what's happening. So how does this fail here then? It's gonna fail with you did something wrong, right? That's the only thing we have. Yeah, it should be this. Okay, so then I do UV run pytest. Okay. Am I not using... What? I thought this was supposed to be, Okay, so there's 2 issues. So why the heck is this? Oh, I'm sorry. This is invalid. Okay. That's why. Okay. All nice and good, but... Huh, the test valid. Okay. So what, this... Really? Did I forget the change here? TODO? Yeah, this should be pass. Why am I getting not pass here? Oh, come on. So I leave this intact. The stuff I have method, which is at the same scope, and I have do not touch. Okay, well, we found the bug then, because something is off here. Very confusing, because I thought we were just testing this, but anyways. We're back to debugging, or what's going on here? Do I see anything quick? Did I change anything? No, it really doesn't seem like it, right? I know, of course, we have this tricky thing here, so I let the new line go. Okay, well, we gotta see this is hard. I gotta see the diffs now. The nice thing about pytest is I can do UV run pytest -k valid, and it only runs a test which includes that, in which this case is both. It would be test underscore valid. Okay, so 1 fail, 1 deselected. So we know it enters that path. Okay, well, I guess we have to stop. I gotta stop. Let's stop here and then we'll continue line by line. But this should be easy to catch though. Okay, so we're here. So let's see the diffs, man. All right, diffs, okay. I am not sure what's happening with my... Okay. This should be better. So I can't really see. Was my font this low? Yeah, maybe this is better, sorry. Damn, my font was kind of small all this time, but it's fine. Maybe I should, now let's go back to keep it consistent. So, print D for D in diffs. We gotta check all the diffs. Ah. What? Did I reverse the arguments? Aha. Because it's saying I took out... Yeah. I reversed the arguments. Okay. Very good. This is an easy fix. Interestingly enough, so the difflib function considers what I see. So the first argument should be the template. This is very important to know then, because my arguments are completely mislabeled here. Actually, it's template and code. All right. And more importantly, they have to be passed like this, because this changes with... Yeah, okay, so I was actually testing completely in reverse. Oh, yikes. Okay, well, good thing we have pytests now, because we can test a lot easier. This should fix everything if you run pytest. Still fail. Why fail? Oh, well, because I didn't, of course I have to actually pass them in. Template valid and template invalid. I'm guessing the invalid is invariant to... Yeah, that sounds about right. Yep, there we go, 2 passes. Okay, good. That's it. So we have the diff functionality in our utils. What we have to do, the final thing left, is to integrate it in our PM. We have the test code we append to, and we're also going to say allowed changes will be to do. Okay? And once this guy sees this, to be backwards compatible, we'll say allowed changes string or none is none. Okay? And he'll do from stream.language.utils import the thing we just wrote, validate with template. And he's gonna store the allowed changes. I need a template TODO. This is not template aware, right? It is not template aware. Template changes string or none. It's not too bad. It is getting a lot of args, but we can clean this up later. We are getting a bit some args. It's kind of hard to keep in track here. So string none. Okay, so where do we want to check here? Where do we want the check? We also have to actually use it. So template changes. Now let's see, do we have this template? Yes, we do have the template, because it is actually the template. Yep, after the split, right? Because the AI is supposed to work. So we're gonna do this check before we put the test code back. Okay, that makes sense. Because otherwise we're gonna get the deletion there, and that ain't gonna be good. So actually this should be an early. We should not even attempt to execute it then. Let's see. So where do we do the code? So we get the code advice. Here's the advice. Pass successful message, get partial success. Here we go. So if it's code, where do we concatenate it though? Ah. I think we should write this, we should move the right code. This should not be global. Yeah, I made a mistake here. What is right code? Does it walk through the keys and the items? And I walk here through the keys and the items? Yeah. Okay, then we can eat this here. So for code outputs only. So the logic will be this. Write the code to disk. So then we'll see optional. Validate the code against the template. Okay, so if self dot allowed changes, or let's say template changes is not none. Is the empty string none in Python? Bool. That's a trick here because yeah, okay, so sometimes the template may be empty. Maybe we want the, although that doesn't make sense, but okay, yeah, so let's just explicitly check for the none instance, because you'd be tempted to logically check if not self template changes, but it seems, why take that risk? So if it's not none, then we're gonna do stuff dot dot dot. Now we're gonna write the code, but we're gonna have to wrap this a bit because let's see. Yeah, we should not do this. So why do I need the project? Code and file. No, path, which is path. Okay. So I don't need all this thing, right? To code to file. I just need a tiny, teeny logic here. Which says like this. So yeah, extra is string or none. I can just handle all this on the outside, right? Yeah. Right, so just join with the extra if extra else code. Oh, let's see, okay. With open path, right code. Okay, this is all nice and good, but I will need now to handle all this stuff on the outside. So it won't be outputs. It will be outputs.name.code, which is fine. What it would used to be here. Oh no, this is not gonna work. Actually, it's like this, right? And self.project.files name.path test code name dot get name or none. Okay, So then we go UVX rough format, okay? Much cleaner now because we write the code here. And then we can say, if we have a template, valid feedback will be, what is the function called? Validate with template. Can I dump some utils from here? No, I cannot dump utils. I need project, right? Yeah, I need project and I need general use statement. Okay, I do need. Okay, this is pretty, I mean, this is honestly, this is like, we don't even need this write code anymore. Yeah, I doubt I will use this anywhere else. So validate with template, and it takes self.template changes the code, which is outputs name.code before merging, and self.allowed changes. And then we say, if not valid, advice for the name is the feedback. So now finally we routed this back to DSPy, which is pretty nice, right? It took a while, but we chained execution with, we changed templating with DSPy feedback in this module we had already written, so we're able to reuse that. And also, what should we do here? I guess we'll have valid true. I guess it should be if not valid or no, but this is very dangerous. Like passive messaging can have partial success. I don't like this. Should we just early exit, I wonder? Because we can always write, actually. Oh, we can write, because... okay, now we can write. We didn't need to do that change, right? Because the write doesn't... I mean, it's from disk, but we still had the output. Okay, I got tricked here. We should... Well, that change wasn't necessary. We could have just written everything before. Yeah, and here we're just gonna validate. Of course, we're gonna set all success false. Then we're gonna try to execute and see, this attempt should be first, right? Yes. So write the code to disk, store attempt and truncate trajectory, right? Attempts. Then we validate the code against the template. We get some advice. If the template changes is not none. Well, actually, we should put this logic in then. Let's do it this way. So template string none. If template is none, return true, empty string. Okay, so we're gonna add a pass-through to this function because I don't want to put an if here, right? So let's just do valid feedback with template changes. If it's not valid, I populate all success with false and the advice. And I continue now. I guess I can do an else here. Yeah, maybe like this, right? Nice, so I can also use artifact. I can also use artifact path here then. All right, yes. Project file map, I'm guessing file map is what? It's a thing with paths, right? Yeah, dict string path per, good, not bad. Okay, yeah, this is actually way better. So then I can do, where were we? Feedback, okay. So I have the artifact path, I write the code to disk. I also store the attempt and truncate, and then I validate the code against the template, no longer optional, but it's fine. And if it's not valid, then I am done. Well, I failed the success and I give the feedback. If it is valid, I do attempt to execute the code, which runs a sub process, okay? And if I don't get the success message from this sub process, the message is the feedback. Message is always feedback. All success. Early external success reaches zero and failed to generate code for all outputs. This looks okay-ish. That's it, we're done now. So then I just take the template here, and this other one I don't do anything because these are guys none. Test code is also none. Yeah, we're done. Okay, a lot of changes. So UV lock. Tests. Okay. And let's see, what else did we add? Source, stream, language, utils. Add templating and tests for it. Okay, then what else do we have? A lot of stuff. We also did stream language PM, stream language template PM. What did we do in project? Oh, a bunch of stuff, right? Yeah. Oh, we changed the thing here. Oh, sorry, the completed one we want to ignore, right? Okay, so we should touch git ignore then, because we would like to AI outputs. So we should ignore src, stream, language completed pm.py specifically. Is this gonna work? It should. Stream language complete pm.py. Git ignore. Commit -m integrate templating. Oh, come on. Why? src stream. What's happening here? Raw format. Oh. PM star.py? No. Why can I not ignore this? Is it like a Windows path thing? Oh, it's gotta be a Windows path thing, right? Ignore specific file and git ignore Windows though. We have to remove it. I know why, because it's in the index, right? So git rm stream language completed pm. Git rm cached, because we do want to keep this file. Remove AI generated file. Yeah, we don't want this. But we don't want to ignore it. Okay. Even though it's still on disk now, right? Yeah. Same for the instrument. So src stream language completed. What do we have here? Instrument. Yikes, I should not have done that. So git, well, I should do touch. Okay. Well, actually, no, I don't need to do that, right? Because we don't need that file. Okay. Git add, git ignore, git, and we'll do the same commit. Okay, before we drop off, not too long. Yep, it's perfect. So let's first try the app, the initial app. It's been a while since we did it, but stream.main. Now it has feedback. We already have that, and we want it with files. Let's see. This should work. Well, of course, it does the whole iterative thing. It writes to disk, measurements, cases, blah, 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 all the test code, but this should be good enough to work in Python. And then we can actually try the PM code. This should also work now with execution, and we are done. So yeah, we're done with this. We're done with templating. We use the unified strong diff. We gotta monkey patch those files, which is not as easy as it sounds. Is this thing working? What's happening? Is it attempting to do something? Is it stuck in an infinite loop? Not quite sure what is happening here. Not too happy. Did we break it because we're not writing all the files? No, but the execution will be in... We may have broken it here. We should write all these at once, right? I guess their order is still valid because the first file being written will be... Yeah, we broke this for sure. Where? We're still waiting for the AI. Yeah, we're still waiting for the AI. Okay, the AI is slow. Maybe we didn't break it then. Interesting. Maybe we max the requests though with the free key. That could be a problem. Which I think is the case. Oh. Feedback 119. Oh yeah, I know what's happening here. We can't always write the test code. If self test code else none, right? If extra else code, yeah, we have to do it like this. Extra format, get status, get add stream feedback, bug fix, push. Okay, let's hope the requests go through. Oh, it did go through. Okay. The test measurements runtime. Something is hallucinating here because let's see. Cannot import measure runtime, right? So what the heck does it do? From solution. This is fine. What it did not was not smart enough to figure out. We busted up the test. Oh no, this is valid. Why did this not run? Did it like fail the assert? Is it stuck in a death loop because the model's not that great? 1, 2, 3. Oh, it did get incorrect result. Yeah, okay, so sometimes there's no infra bug here, but the model's just too weak to figure all this stuff out. I'm kind of sketched out. I think this works though. Let's try to run the PM. -m. Stream language PM, and that's it because it's in Python and it has the template to pm.py. Let's see this PM if this works as expected. Looks like it's working because where do we write the file now? Is output meta? No, we write it directly where it's supposed to be, which is stream completed PM. Here we go. Yes, this is PM code populated. It didn't create the folders. Okay. which is probably working through that error. Come on, crack it. Okay, yeah, we're on the free plan, so the model does take a while to respond. Well, maybe we'll get some credits for next time. We need donations though. We don't have a sub button. But this thing is slow. It's probably figuring out that, oh, I need to create the folders now. And I want to try something else because the template is cheating for Python. Okay, because the template is telling it, okay, so we should. Okay, let's see. PM complete? I don't think it worked. Right. Is my template not hit? Interesting. I wonder why do I get a because this seems like a template hit though. So what is the PM outcome? Let's see. You did something wrong. My template is, yeah, my templating doesn't work because it's way too aggressive apparently. But the thing is, okay, so let's the templating is too strong, but this is fine. This is easy to fix, right? I wonder why. Well, let's look at the utils a bit. Let's turn this into a test actually, right? Because here's the nice thing. We know, okay, here it is. So we know this code. Okay, so we're gonna test, where's the pytest? Here it is, test template, okay? So we're gonna say what was it? Add fixture, no, pytest dot fixture, define valid complex, valid pi, str, return, just dump the whole code here, which I believe is perfectly fine, yes. Dot strip. Aha, is it a stripping thing? I believe it could be. No, but we strip everything though, right? Let's see this test. If this test... Okay, and then we also have the template. If this test passes, then we know something is fishy. Template py. And I believe it could be the strip. Return and we know that the template is always this, without the main. Oh, sorry, not this, the template PM. This one. Here we go. Okay. Dot strip. Does it want like this here, or what is it yelling at? Is this not a thing in Python? Oh, come on. AX is ... No, this works, right? Like triple quotes supersede everything. So then we just need to do define test valid pi with template. Valid, well, we should reverse these. Template pi str, valid pi str, allowed change str, which is fine. And this is actually the same, except it's valid pi and template pi. Okay, we should switch this template valid just for fun, and template invalid. All right, UVX rough format. Okay, so if I do UV run pytest k pi, it should only, so something really fails here. Okay, valid pi. Interesting. Okay, well, this is a good find, because what the heck is happening here? So let's see. Did it change the args? See, sometimes it's hard to see. So then we need tools like online. Well, no, we don't need, I was about to do something dumb, but we have it in Python. So let's see the diffs then. Let's print the diffs. Okay, so we go back to our classical debugging. We stop here and we're gonna print all the diffs. UVX run k valid pi, there we go. Print d for d in diffs. I see it, it's this last line already. But oh, what is this? Auto-generated. Why does it spill on the new line? This is the bug then. Yeah, this is a disaster, but what the heck is happening here? So, oh. Interesting. I need to escape new lines. Okay, so we need to escape new lines in this string. This should not be read as a new line. It should be read as exactly these characters. Okay, very good. This is a classical string issue. Haha, nice find. Okay, so let's see how to, so how do we escape new lines? Interestingly, we cannot. So the AI wants to write a new line, but difflib how to escape special characters Python. So what's the problem then? Because okay, valid pi, valid. Let's turn this into a simpler test. Template and valid new line, all right? Because we're able to isolate the bug. So we don't need a template. We don't need all this. This can go away. It was helpful, but it can go away. What we do need is a valid new line. And we can just take the template and do exactly what we did, but on a much smaller scale, right? Because what if I had changed it? Print some stuff with, so let's see, print new line -n. Right, so now if I run UV put this on a new line, Still gonna see a fail. Let me take the break. Did we take the breakpoint out? We did not. Well, let's not take the breakpoint out because I want to see this thing here. So then we do the same thing. Print print D or D in diffs. Yup. Very frustrating, right? D0. Oh, sorry. Diffs 0. Diffs of 5. Aha, here it is. So what the heck am I supposed to do here? Like, what? List. So I do print D for print diff for diff in list D compare lines template lines code. So do I need to do? I think I'm gonna need AI for this. I also don't know how to copy this, which is very frustrating. Is it right click on Windows? I believe it is. Hang on. No, I don't want to paste 22 lines in the terminal. Yeah, I think it is right. Okay. But if I do, so what do? Do I do import RE? And I do re.escape? Yeah. But had I had this like this, I'm guessing this passes now, right? Yeah, okay. So I just need to escape. Oh, come on. This gotta be easy, right? Escape characters in Python. Okay, now I have an issue that my modified string has in it. This needs to be like that because it's code. Is there a way to escape it by post-processing? I think I just have to like, oh, it's repr. Oh, okay. Well, this is easy then. I knew it was gonna be like this. It's just repr then, right? Yeah. So it's just repr. I guess we can take this one too, just to be safe if we ever decide to include. Sorry, it's the other way. It's repr template split lines and repr code split lines. That's it. This should be it now. So then we go da. What the heck did I do now? I know what I did because there are also new lines in the code. But my example is more complex. N is inside the print there. I want to keep the code indentation and new lines, but not internal ones like in the print. Wrapper ruins everything and converts all the code to a single line. Tricky. Not, you want to preserve structural new lines, yup, but you want to escape data new lines, so they don't look the most preserved tokenized. Oh, yeah. No. And escapes the new lines only within those bounds. I think we have to do this. Untokenized modified. A clear way to rebuild code for tokens while modifying them. Right. String. Damn, this is brutal. Nah, I think I'm just gonna replace statically. Forget about this, right? Because look at here, I have code. Yeah, okay, so then it's easy, right? Escape new lines in strings. Because I can do new lines and tabs in strings, right? So I'm gonna do this. Template is template.replace. Return a copy with all cards. Okay, so it's a copy. So the old will be dash dash dash, and it'll be replaced with dash 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 dash. And I can also do dash dash t. Okay, so then if I do, looky here, I do code dot replace dash 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 n with a double escape then. And that's it. The other new lines remain. Yeah. Forget about it. We're doing this for sure. T, and then we do exactly the same thing, but for code. There's probably other trickery here, like escape special characters. I guess you want also. Nah, but we can't. We gotta be a bit careful here because we can't do the dash dash. Yeah, we What about the new line character? That one is trickier. It's dash dash n. Okay, that one is trickier. Damn. So we don't need the wrapper now. We can't do the wrapper because it ruins the new lines. And we're just gonna leave it like this. Again, UVX rough format. Oh, interesting that this is not reformatted, but whatever. So let's test with the new line. Okay, moment of truth. Oh, whoops, didn't mean to do this. Now I gotta delete everything. The moment of truth is print. It's print D for D and diffs. There we go, finally. All right, so we have an escape new line. Very good. Very good. Nice. So no more breakpoint. Whoops. Okay, good status. Add src stream language utils tests. Git commit. Escape special characters inside Python strings. So let's try again. Let's try our project manager again. Now, the feedback should whoops. Did I not save? What did I do here? Ah, my bad. Remove breakpoint. So it'll be src stream. What is it? Language utils. Get push. So let's try. Now we can try our project manager software again. And this should really be it now. Aha, there's a Python error. Because, there we go. So the code decided to, magically remove. There we go, perfect, nice, nice. So we got some feedback too, because the project manager first decided, I'm just gonna remove the right jagged array to file. Let's look through the history, right? So outcome, PM outcome, you did something wrong. This is the template thing hitting it. You did something wrong again. You did something wrong again, and until it finally works, I'm guessing, right? Yeah, and now if we try to run the project manager, which also has test, and we say uv run-m stream.language.completed.pm. Oh no. Is my templating still hitting me? What I don't understand is why. Yeah, because he never gets to see this error because so hang on. Let's take. Yeah, so something in the template is still hitting us, right? I'll bet you it's that. It must be that, right? So let's just stop a bit in the utils then directly while it's running. Let's see what's happening here. This should only run once per attempt, right? Because we only do one validation at Oh, not this. Sorry, I need to run the language PM again. Okay, so we are here and we do our trick. Print D for D and diffs. Let's see what changed in the template. This looks good. See, the thing is I would expect... Here's the corner case we don't find. If I'm in a streak and I leave a line alone, am I allowed to do that? Oh, that's the bug then, right? Yep, here it is. So if I leave a line alone and I'm in a streak, why do I put it false? Why do I end the streak? So our logic is broken here, right? Because here he leaves the line alone, but it ends the streak, and now a minus starts without the streak, and that's a bug because here we go. You did something wrong. So I'm in a streak. I think it's fine if I see a changed line. So who gives me streak? Who ends my streak then? The indentation level does. Okay, so we get the indentation level and we say, and it has to be outwards. Okay, so going outwards does that for me. Okay, so the logic is if, so let's get the current indentation level, right? So indent current. I think we can always get this, right? Yeah. Okay. So then we have the indent current. We don't need this anymore. New lines are always valid everywhere, I guess. Yeah. So if indent current is greater or equal than indent allowed, some old code is left intact in this streak. This is fine. So we do nothing, but otherwise we violated the streak. We exited the indentation level of the streak, so can't continue, right? There's no way the streak can continue. If, yeah, the only caveat, yeah, this is fine, right? Because otherwise, yeah. And this also includes new lines, right? So if we leave a new line in after the to-do, for example, this would still be fine. This looks good. Do the pytests still run? No, the pytests do not work anymore. Because this is the old indent allowed. Ah, shit. No, this should be captured, right? So you're telling me if I put this... Is it this or no? Nuh-uh, it's not that one. It's actually the functional change here. Like, is it this? No. Do I ever pass the what's happening here? Sorry, what? Can I just stash? Yes. Oh, I just failed that. Okay. All right, so we have to, oh God, get stash pop. This is independent, but we have to fix that bug now. Okay, so there's no way to do it. I have to stop here now. Is it because of the escape, I think. This seems... Oh, this is actually brutal because it's not guaranteed. What? The minus never appears in front of the plus? Yikes. So my logic is all wrong then. Gotcha. Okay. So there's a problem because sometimes the plus appears. Is there any way to order the minus to appear in front of the plus in difflib? Please say yes. Line unique to order. Yeah. Well, this is pretty rough, to be honest. So the order is not guaranteed here. So I get the plus. So then I don't start the streak. So then I can't do that because I need to know there's a to-do, right? I guess I can start. Once I find the diff, I count the block. There must be a to-do in it. Either removed or left alone. So it's either minus or, which is this thing, right? Yeah. I see. So then I can defer the comparison with the indent allowed. Yeah. And only do it when the streak ends. So where does the streak end? Run the deferred comparison. Because I found the minus. So this eventually finds it for me, right? When I'm not in the streak, and I set the streak. This guy doesn't care. He can always... Or what should I... If I search for every line change... Maybe it's easier, right? So I just keep it growing the scope. Yeah, I think it's easier. So for every line change, I record its indentation. Actually, no, for every line in the diffs, I record their indentation and whether they have to do or not. Then for all changes, it's like a level set basically, right? For all changes, I find the nearest to do. Well, no, I search that level set, and if there's no to do in that level set, then it's invalid. This will allow changes before and after the to do. But it's fine. We have to give that up. Okay, so it's time for refactoring this. Forget about it. Yeah, we'll just do it like 2 pass, right? So Yeah, like this, right? So we don't need any, so we just need indents is none for the indiffs or diff in diffs. And we also need has allowed is false for diff in diffs. Populate the indent and whether and marker for each line. So for diff in diffs, let's do an enumerate, I guess. Right, because this is synced, and then we say if, how do we get the indent? We break the code into two. Now there is a trickery here. Okay, there is a trickery here. So we take the previous indent, right? So we know Python code has to start from 0, right? Yeah, so then we say we're going to consider new lines as part of the level set. We're just going to glue them together, which is fine. This doesn't matter, right? Because even if you have two level sets and then they're separated by new lines, you actually want that. Yeah, you need that. And as long as the level set changes, then yeah, it's all fair game. There's no way to trick this, I think. Eek. Ooh, yeah. So then indents of I is indent current. We're done. Treat new lines as part of the previous level set. And we just need the other thing is much easier. So if, it's actually very easy, right? Because it's if, what's the prefix thing? Oh, here we go. Diff code strip starts with allowed change. Allowed of I is true. Okay, that's it. So we populate the indent marker for each line. And I don't even care what the type is here, okay? Now, for each changed line, determine if an allowed line is on its level set. So it's a we'll do a quadratic then, yeah. Yeah, we'll do quadratic because there's no, well, we could do it forward, backward, I guess, but I don't think there's any pure forward way to do this because of the inversion that happens here. I was not aware that. I thought this would preserve some semblance of order, like it was first show you the minus lines and then the pluses, but seems like there's no guarantee here. Okay, so we'll go for I diff okay, and we'll have diff type this time, and these guys. Okay. If diff type, we only care about in minus plus. Yeah, this is drastically different because now we leave the tag lines are always good, right? Which we kind of handled before. So then we do a two-pass thingy, right? Search for, so then we do found equals false. So we do valid equals false. And then we can say search for to do after, search for the marker below, and then search for the marker above. So we're gonna go for j in range. Now we start from I+1 and length of diffs, okay? And okay, so then we also take, no, valid is true, right? And indent current is indents of I, okay? And then if the diff type is, okay, and then we say if the level set can go down, but it can't go up, right? No, this has to start from false because we have to seek the to do, right? So then we say like this: if the current indent is greater or equal than what is it? Indents of the position that I seek, and sought other type, other code is diffs j so I need the other code stripped to start with the allowed change. Then I found it. Valid is true. Break. Search for the marker above. So then we can say, we'll just search for it. It doesn't matter. I-1. Should I search for, what do I look at the current letter or the current index too? So if the line in focus is a to-do line, I will not find others in the streak. Yeah, it should pass, right? Marker lines should auto pass. So if allowed I, oh, I'm so dumb because I should have just done and allowed J, there we go. So if allowed I valid is true, and we can break the big, no, we can, we'll just set it to true, it's fine, it doesn't matter. Actually, this doesn't matter either, right? Yeah, forget about it. And then we'll just seek range of I, so 0 to I, yes, and then the I, and then I+1 to length. Okay, good. So then it's exactly the same logic, actually. Well, okay, then I should just do like But Python range without an element. Should just do this, right? No, actually I don't want to do this because it's a level set. So, okay, if but I can also break this early. So if indent current, no, this is less than or equal. Yeah. So if it's at the same, or if the two do, nuh-uh, there's a tricky here, because if I have a to-do in the outer scope and then one in the inner scope, I think I need to search for this exactly there. Then I won't accept anything else. And then if I go outside, then it's over. There's no point in searching because I left the scope somehow, right? Yeah, either I hit the new line above me, which is the termination of the previous scope, which could be lower, or I hit the new line, or the thing after the new line below me, which is also the next scope, which could be lower. So I actually lost my chances here. Same here. Once I hit this, it's done. So I'd better find that. Here, let's give some instructions here. Some better feedback, right? Else the feedback is what? Oh, I guess nothing, right? Okay. Valid feedback. This logic can all go down the hill now because it's definitely broken. The funny thing is this is a lead code problem, which is what we want the AI to solve, but in writing this we have to solve it ourselves first because we want to do AI with it, which is really hilarious. But it's fine, this is the point. Okay, so now if I run the pytest, let's see, interesting. Sorry. So I need to return this, okay, and an exclamation mark. So the test now becomes here. Oh. Oh, this is so annoying. Okay, this one is fine, but I can't catch anything though. Why? I get everything false now. Well, let's see what we have in a new line test, for example. Or I guess the I guess we can run the basic one, right? Okay, so we have, what do we have here? Our indents and allowed. This seems to be fine, right? So valid, false. So 1, 2, 3, 4. Oh no, 5. Yeah, these guys are all connected. And where is the diff? Zero, 1, 2, 3, 4. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Oh, wait a second. Oh, sorry. It's I need a valid of I is, no, I need a valid which is false for diff in diffs. And let's see, so yeah, if allowed I valid. I guess it can be allowed dot copy, right? So then all the marker lines will auto pass. Nah, let's leave it like this. Let's leave it like this. It's true. It's harder to read. Okay. So then we have valid I is true. Okay. If not all, I can do an all, right? Return all valid. And this will be I again, and this is gonna be I, because something weird is happening in the last row. Ah, yes, because of course, or diff type. I forgot to do anything about the leftover, the lines that are left alone. Still, well, let's see then. Still not. So what do we have after this then? Curious to see what's here. Valid. Oh, almost. Why not those? Print D for D in diffs from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. What's happening here? Okay, but then what? So I can't seek anything here? This seem like D and diffs. They definitely have a to-do neighbor. What is the indent of 5 and 9? Indents. That 0 is wrong. I thought new lines were supposed to. I forgot to update. Jesus Christ! I forgot to update indent previous is indent current. Okay. Which I believe in Python works like this. Yes, you can do a double update. Okay, again, I'm getting there. Valid. 2 more mistakes. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Valid 10. False. What is the indent of 10? Indents. Diffs 10. Okay, well this is pretty basic, so I remove the dots. So what? And what's the problem with this? Allowed 10. Shouldn't it have like the neighbor allowed 9, which is right above him? Yes. And what? I can't. Huh? It's a minus type for sure. And for J in range 10, oh, wait a second. I need to count downwards. So I count from I -1, -1, -1. Yep. All right, next. See, because I search upwards, not from the beginning, because then I find something with a small indent, like literally the first line, and I don't actually search for it. We are done now for sure. There we go. So UVX rough format, UV run pytest. Oh, more breakpoints? No, we don't want to. Oh, did I not save this? Sorry. This happens all the time. Overwrite. Okay. UVX rough format. Okay. UV run pytest. Feedback is none. String or none. Wait, what happens if I get non-feedback? UV run pytest. I think this is fine, right? Yes. Nice. Okay, a lot of fixes now. Git add src stream language utils. Git add the tests. Split. Rework logic to. This is forward backward search. Yeah. I don't think it can be made. Well, it probably can be made even more efficient, but whatever. You can just like. No, yes, you can. You can just glue like things. So. Like you start from a line, you search downwards, and if you find something, you mark all the in-between lines as valid too. Like you don't need to research for the next line, but we'll do it like this, it's fine. Let's try the project manager again. Should really work now. So UV run -m, stream, famous last words, language, PM. So the PM will populate its template, and now it should finally, the templating should finally let it go. And okay, we should see some real feedback about, there's a make dear already, I see it. Now this is either the right implementation by, there we go. It fixed an error, boom, boom. Finally. Okay, so now if I run -m stream language, please work, completed dot. Okay, it actually works. So we now have, okay, we did it. So we wrote a DSPy code that takes care of the file structure. Now let's do the final thing. Let's cut the cheating down. Okay, so no more tips about Python. There we go. A small difference, but kind of a big difference. Also, it writes this output meta now finally, which I guess names the variables like this. Okay, so we also handled the array writing, which is not an easy thing. We should also git ignore the output meta. Well, actually, we should ignore output something. Okay, and what we're doing now. This is pretty important because we git ignore and git commit ignore more things. And what do we have else? Git diff. Whoops. Yeah, so we're gonna remove the cheats from the template. And finally, so remove Python cheat codes from template. And let's do one more run. It should really work though, because we wrote a test which is helpful. Okay, let's run the PM again now. Let's see. Nice. Okay, so now the PM, the completed PM, let's see, what's it gonna do? Well, it's pretty interesting because it'll probably return the pi suffix without the dot. But then the test should kind of... Oh no, it figured it out. Okay, make dir. I guess this is enough because we don't have UV in our test. We need execution. Okay, it wrote the array. Yep, that's it. Is it? Where's the output meta? So where's my history here? Is the template slipping again? We found even more bugs. So you would really think, what the heck happened here? So there's no way this is not valid. There's also no way this is. There's also no way this is not. What did it? It didn't nuke the dependency map or anything, right? Yeah, this all looks fine. Did it mess with the types in the array? Nuh-uh. It respected the open. Oh, come on. Well, we have to debug this then. Again. We're just gonna make a test out of it. Did it do some weird things? No, it didn't do any weird things. So we'll do a pytest fixture. Valid pi. We'll do the same thing we did last time. And I think we're gonna keep this one if it's... I don't know what happened though. Okay. Dot strip. Maybe it is a strip issue. Doubt it. And we also have a fixture which is template pi. String return dash dash dash. So the template we know is this. Okay. Very curious to see if this passes our implementation. Dot strip. Is there like a... Is it like an extra new line? No, there's two here. Although new lines should pass. We literally took care of that. UVX format. Okay. And then we just want to test a valid pi with template. py. Whoops. Valid pi. And then we're going to take in template py, and we're going to take in valid. We're going to feed it here. We're going to take in valid py. We're going to feed it here. And then we're going to do UVX rough format. And then we're going to do UV run pytest -k valid py. Okay. What? Is it like I'm not seeing the... Okay, so the PM passes the test. Did the code crash somewhere? Okay, so wait a second. Can I run the PM? What am I doing? Can I just run UV? Oh my God. Of course the output meta is not there because I have to run the... Okay, I just wasted like a ton of time. Yeah, everything is good. We are all good. Good. My bad, because the reason why the output meta was there because I actually ran... But wait, shouldn't my execution... Yeah, it works, everything works. But why doesn't my execution code run my PM? Because my PM uses the module with code feedback. So I passed all the feedback. Or did I not? No, we passed the feedback because we just checked it, right? So let's add this. Okay, I think this is all. Anyways, it's working. This is it. So we have the thing. So we're just gonna add this harder test, and we're gonna look into it more. But bottom line is, even if I did get something wrong, it's probably some small logical thing in the unified diff. It kind of sucks that it ended up being this complex, but I don't think there's any other way. We did have to deal with a lot of subtleties though, which was pretty nice. We learned even this unified diff, we must carefully escape characters in it, which is pretty interesting. This is specific to compare to doing unified diffs between code, right? And indentation levels, because you want to preserve these in Python. So all in all, I would say this was really nice. And yeah, we have project management AI now, which is capable of writing a file structure, or even better than that, writing code that writes a file structure to disk. So that's it. We solved half of our problems. The other templating we need to do is we need to somehow template code execution in arbitrary languages, which doesn't sound so hard now. If we know the AI was smart enough to write files, it's probably smart enough to run code and generate use statements between different code modules. But again, the AI is capable enough to grasp some of, how to generate the project, at least for Python. And this is also a cheap AI, right? It's the free NVIDIA Nemotron model that we've been using all along, Nemotron 3 Nano. This looks pretty nice. So yeah, thanks for watching, and we'll continue next time.